Hello, my dear JEE aspirants. Welcome back to another show. This time 2024 JEE main continuity and differentiability. I'll be covering both January and April shifts. Okay, quite interesting questions are asked from this topic, continuity and differentiability. I've been discussing JEE main 2024 of both April and January shift. And number of questions asked from different topics. We'll see first. Number of questions asked from finding unknowns using the continuity definition. 6 questions are asked. Based on differentiability, 2 questions. Continuity and differentiability, 5 questions. Discontinuity of the greatest integer function is 2 questions. And 1 question is asked on functional equations. Totally we have 16 questions altogether from continuity and differentiability chapter covering both January shift and April shift of 2024 JEE main. Take the questions one by one. First question given like this. A function f from R to R be defined as f of x equal to a minus b cos 2x by x square for x less than 0, x square plus cx plus 2 for x between 0 and 1 including 0 and 1, and the third line is given as 2x plus 1 for x greater than 1. So f is continuous everywhere in R and m is the number of points where f is not differentiable. Find m plus a plus b plus c equal to how much? Okay, so need to find the value of m, a, b and c. Okay, then you have to add those. So already told that function is continuous in the set of real numbers. So it is, in particular, it is continuous at x equal to 0 as well as x equal to 1. 0 and 1 are the points which is highlighted here, correct? So the function is continuous everywhere in the set of all real numbers. In R means minus infinity to plus infinity. The function is continuous everywhere. So I need to find the values of a, b, c using this, and m is the number of points where the function is not differentiable. That I'll find afterwards. Using the definition of continuity, I'll find the values of a, b, c. They told that function is continuous everywhere, correct? In the set of real numbers, from minus infinity to plus infinity, the function is continuous everywhere. So the function is continuous at x equal to 0 as well as continuous at x equal to 1 also. The function is continuous at x equal to 0 means use the definition of continuity. Left hand limit equal to right hand limit equal to function value. Okay. Function is continuous means left hand limit equal to right hand limit equal to function value. I'll be using that. F is, first I'll use continuity at x equal to 0. Okay. Then I'll use continuity at x equal to 1. So I'll get conditions on a, b, c so that I can find the values of a, b, c. Okay. Assume that f is continuous, given that f is continuous at x equal to 0. Using f is continuous at x equal to 0. F is continuous at x equal to 0. Okay. Implies left hand limit equal to right hand limit equal to function value. Okay. Left hand limit will be limit x tends to 0 minus. 0 minus means x less than 0. X less than 0 to use that function. A minus b cos 2x by x square. F is continuous at x equal to 0 implies limit x tends to 0 minus. What is my function for 0 minus? A minus b cos 2x divided by x square. Correct? Limit x tends to 0 plus. 0 plus means x greater than 0. That is x greater than 0 you can see in the second line. I had to use that polynomial function of degree 2 there. Limit x tends to 0 plus. Limit x tends to 0 plus, what is a polynomial function? Given x square plus cx plus 2. That should be equal to f of 0. Correct? Left hand limit equal to right hand limit equal to function value. Left hand limit. To evaluate this, no, as the denominator is tending to 0, as x approaches to 0, denominator is becoming 0, right? So numerator also should tend to 0. And for this, I can apply limit directly here. X equal to 0, but 0 square plus c into 0 plus 2. So right hand limit becomes 2. Right hand limit becomes 2 at x equal to 0. Here for left hand limit, as denominator is approaching 0, numerator also should tend to 0. Because f of 0 I can calculate. F of 0 is also 2, no? At x equal to 0. 0 square plus c into 0 plus 2. F of 0 is equal to 2. That means function value is 2. Because the function is already continuous, function value is already 2, correct? Left hand limit should also be equal to 2, right hand limit also should be equal to 2. So left hand limit is a 2 means this limiting value is a finite number. So as denominator is becoming 0, numerator also should tend to 0. Otherwise it becomes a contradiction. Numerator is non-zero, denominator is 0. Non-zero by 0 means it becomes infinite. So as limit is already a finite number, limiting value is equal to 2 because the function is continuous. Left hand limit should be equal to 2 because function value is already 2, correct? So left hand limit is 2 means limiting value is going to be finite of this. So as denominator is becoming 0, numerator also should tend to 0. Otherwise limit becomes infinite, which becomes a contrary to the given statement here, to the statement which you have written here, correct? So as x is approaching 0, denominator is becoming 0, numerator also should tend to 0. I'll use that and get the values of a and b. I can get the condition on a and b. I'll write here as x is tending to 0 minus, denominator is tending to 0, implies numerator should tend to 0. Numerator should tend to 0. Numerator what? As x tends to 0. As x tends to 0, numerator will be here a minus b into cos of 2 into 0. Cos 0 is 1. Correct? That should be equal to 0. Correct? That means cos 0 is 1. B into 1 is b. A minus b equal to 0 I'm getting. A minus b is equal to 0. That means I'll get a is equal to b. I'll get a equal to b for this. Okay? So what I'm getting is limit x tends to 0 minus, limit x tends to 0 minus, because a and b are equal, I'll take b is same as a, so a into a minus a cos 2x, because b is equal to a, I got the condition. I'm using this condition here, so that a is common. What remains is 1 minus cos 2x divided by x square. Limit x tends to 0 plus of this polynomial is going to be equal to 2. Even the function value is 2. Okay, 1, 2 is enough for me here. And we know the result, limit x tends to 0, 1 minus cos bx by x square is p square by 2. I'll be using this result. Limit x tends to 0, limit on trigonometric function, you must know this. 1 minus cos px divided by x square is equal to p square divided by 2. Learn this shortcut method, already it's done in limits. Limit x tends to 0, 1 minus cos px by x square is p square by 2. Here observe that p is 2 here. Compare this and this. Correct? 1 minus cos 2x by x square. P is equal to 2. So 2 square by 2. In place of p you put 2. 2 square 4. 4 by 2 2. Value of this is 2. So I am getting a into 2 is equal to 2 implies a is equal to 1. If a is 1, b also 1 because a and b are equal. So I got the values of a and b. Because a is equal to b, we have that condition. Correct? So a is 1, b is 1. We got. Now, I can get the value of c using continuity at x equal to 1. Function is continuous everywhere. In particular, it's also continuous at x equal to 1. F is continuous at x equal to 1 implies. F is continuous at x equal to 1. F is continuous at x equal to 1. Implies what? Limit x tends to 1 minus f of x. Limit x tends to 1 minus. 1 minus means x less than 1. What is my function there? Polynomial function of degree 2. X square plus cx plus 2. That should be equal to. Limit x tends to 1 plus. 1 plus means x greater than 1. That is 2x plus 1. 2x plus 1. Correct? Left hand limit equal to right hand limit equal to function value. That should be equal to f of 1. Here you apply limit for this. X tends to 1 minus 1 square. 1 minus means indication of left hand limit. Not to put minus 1. 1 minus means indication of left hand limit. The value of x is approaching 1 from the left side. Slightly less than 1. Put x equal to 1 and write 1 square plus c into 1 plus 2 is equal to right hand limit. Put x equal to 1 there. 2 into 1 plus 1. So what I am getting is 3 plus c is equal to 3. I am equating the left hand limit and right hand limit. The function value is not required. The third one is not required. Enough to get the value of c from these two only. So c is equal to 0 I am getting. C is equal to 0. A and b are 1 I got. A is equal to 1, b is equal to 1, c is equal to 0. I need to find the value of m. What is m? According to the question, m is the number of points where f is not differentiable. So I need to find where the function is not differentiable. Only doubtful points are 0 and 1, correct? 0 and 1 are the doubtful points. So at 0 I have to find out whether the function is differentiable or not differentiable. Even at x equal to 1 I should find out whether the function is differentiable or not differentiable. For x greater than 1 it's differentiable. For x greater than 1 the function is 2x plus 1. 2x plus 1 is a polynomial function of degree 1. So it is differentiable, correct? And for x between 0 and 1 also it's a polynomial function. It's differentiable. And for x less than 0 it's a quotient of two functions. And that too a minus b, a is 1, b is 1 we got. Correct? 1 minus cos 2x by x square. For x less than 0 is differentiable. The doubtful points are at 0 and 1 only. I need to check the differentiability at x equal to 0 and 1. So to check the differentiability of the function, I need to verify left hand derivative and right hand derivative. Are they equal or not? I need to find out. At x equal to 1 I will find out first. Then I will go for x equal to 0 because x equal to 1 is quite easier. Correct? So putting the values of a and b there and then substitute. Okay, first I'll put use the left hand derivative and right hand derivative at x equal to 1. So at x equal to 1 for x less than 1, differentiate this. C already we got 0, correct? C is 0. So f dash of 1 minus is what? F dash of x, f dash of 1 minus I'm going to write here. Derivative of x square is 2x, 2 into 1 is 2. C is already 0, correct? C into 0, 0. C is 0, 0 into x 0, 0, 0. Derivative 2 is 0, derivative 0 is 0, derivative 2 is 0. So f dash of 1 minus is 2. F dash of 1 plus we find out. F dash of 1 plus. 1 plus means slightly greater than 1. For x greater than 1, function is 2x plus 1. Derivative of 2x plus 1 is 2, correct? So f dash of 1 plus is 2. Therefore, the function is differentiable at x equal to 1. Hope you understand. F dash of 1 minus means differentiate the second line. So differentiate the second line, okay? Derivative of x square is 2x. Then you put x equal to 1. 2 into 1, 2. And c is already 0. 0 into x is 0. Derivative of 2 is 0, correct? So left hand derivative I am getting 2. Even right hand derivative at x equal to 1 is 2. Therefore the function is differentiable at x equal to 1 because both are equal, correct? Therefore f dash of 1 minus equal to f dash of 1 plus. F dash of 1 minus equal to f dash of 1 plus implies f is differentiable at x equal to 1. F is differentiable at x equal to 1. I need to find out whether the function is differentiable at x equal to 0. Right hand derivative at 0 is quite easy, correct? Right hand derivative at x equal to 0. See, derivative of x square is 2x, correct? And this is c is already 0 I got. C is 0. 0 into x will become 0. 2. 0 plus 2, 2. X square plus 2, my function. If you differentiate and put x equal to 0, I'll get 0. F dash of 0 plus, f dash of 0 plus is going to be equal to 0. Correct? Derivative of x square to x. 2 into 0, 0. C is already 0. So 0 into x 0. And derivative 2 is 0. Correct? So f dash of 0 plus is 0. F dash of 0 minus. To find f dash of 0 minus, I am using the first principle formula. The derivative formula. Definition of derivative I am going to use. Because a and b already we got 1. So a is 1, b is 1 if we substitute. F of x becomes 1 minus cos 2x by x square. F of x is 1 minus cos 2x by x square. For x less than 0, for x less than 0, my function f of x is going to be 1 minus cos 2x divided by x square. 1 minus cos 2x divided by x square, my function f of x. I will use definition of derivative of the function, f dash of a. F dash of a is limit x tends to a, f of x minus f of a by x minus a. I will be using that. So, f dash of 0 minus you want, f dash of 0 minus, right? F dash of 0 minus will be equal to limit x tends to 0 minus f of x minus f of 0 divided by x minus 0. For x less than 0, my function is 1 minus cos 2x by x square. Okay? Limit x tends to 0 minus. Limit x tends to 0 minus 1 minus cos 2x divided by x square. And f of 0 how much? F of 0 at x equal to 0. X equal to 0 you can see here in the second line. Put x equal to 0. 0 square plus c into 0, 0 plus 2. So f of 0 is 2. F of 0 is 2. Divided by x. Correct? I am getting like this. You can take a common denominator and simplify this. Take x square as common denominator. I'll get 1 minus cos 2x minus 2x square. That x square comes to denominator, becomes x cube. So I'm get limit x tends to 0 minus 1 minus cos 2x minus 2x square by x cube. We can add one page here. Limit x tends to 0 minus f dash of 0 minus, what I'm getting is limit x tends to 0 minus f dash of 0 minus is limit x tends to 0 minus 1 minus cos 2x minus 2x square divided by x cube. Like this I'm getting, correct? As we had here. 1 minus cos 2x minus 2x square divided by x cube. That x square, after taking LCM, it comes to denominator, becomes x cube. Now I shall use the series expansion for cos 2x to evaluate this. To evaluate this, we can use L'Hopital's rule also, correct? Takes 0 by 0 form, right? Cos 0 is 1, 1 minus 1, 0, 0 minus 0, 0. We can apply L'Hopital's rule, or else we can use series expansion, that is better. Because L'Hopital's rule might take more steps. I'll avoid L'Hopital's rule, I'll use series expansion for this. 1 minus cos 2x, what? Series expansion. 1 minus 2x the whole square divided by 2 factorial, correct? Plus 2x the power 4 divided by 4 factorial minus 2x to the power 6 divided by 6 factorial. Like this it goes on, correct? This is 1 minus of cos 2x minus 2x square. Whole thing is divided by x cube. Here, if you open the bracket here, plus 1 minus 1 cancels. 1 minus 1, 0. Minus into minus will become plus there. This is 4x square by 2, which is 2x square. 2x square, 2x square will cancel. This becomes plus 2x square minus 2x square will add up to 0. Correct? What is left is limit x tends to 0 minus. What is left out is minus into plus minus. 2 power 4 is 16. 4 factorial is 24. 16 by 24, which is 2 by 3. Correct? 2 by 3 x power 4. Then minus into minus plus 2 power 6 by 6 factorial into x power 6 minus etc. Denominator is x cube. We can take x cube common from the numerator and cancel here. And remaining terms, whatever they're inside the bracket, all the terms will contain x. That will become 0. So limit of that function is going to become equal to 0. So left hand derivative at 0 is going to be equal to 0. Correct? X cube is common. So what remains is minus 2 by 3x plus 2 power 6 divided by 6 factorial into x cube minus dot 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 divided by x cube. X cube cancels. Correct? When you apply limit x equal to 0, 2 by minus 2 by 3 into 0, 0. This term into 0, 0. All the terms contains x. Everything limit is becoming 0. Limit x tends to 0 is there. So left hand derivative I am getting equal to 0. Therefore, you can conclude that f dash of 0 plus is 0. F dash of 0 minus is also 0. Correct? Proved just now. So left hand derivative and right hand derivative both are 0 at x equal to 0. The function is differentiable at x equal to 0. F is differentiable at x equal to 0. F is differentiable at x equal to 1 also. Correct? So m is the number of points where the function is not differentiable. So m is 0. Function is differentiable everywhere. Function is differentiable everywhere, correct? Because at 0 and 1 also I got the function is differentiable. Only doubtful points were 0 and 1. At the doubtful points also the function is differentiable. So m is 0. And a is how much? A we got 1. A we got 1 here. B is also 1, correct? Therefore, I need to find the value of m plus a plus b plus c. M plus a plus b plus c is equal to. M I got 0. A is 1, B is 1, C is 0. So answer is 2. Option D is answer. Question asked on 1st February, first shift. Okay, JEE Main 2024. Move on to the next one. Hope it's clear. I'm using the definition of continuity to find the values of A, B, C. Left hand limit equal to right hand limit equal to function value. Use continuity at x equal to 0. Use continuity at x equal to 1. And also find out whether the function is differentiable or not differentiable at 0 and 1. Okay. So with this, we've done the first question. Move on to the next one. F of x is given as mod of 2x square plus 5 mod x minus x belongs to R. M and n denote the number of points where f is not continuous and not differentiable respectively. Find m plus n equal to how much? We know that modulus function is not differentiable at x equal to 0. It's a very familiar result. Correct? And using that case, mod x is not differentiable at x equal to 0. And I'll discuss two cases, if x greater than or equal to 0 and x less than 0. Two cases. because mod is there. Now outer mod is there. Inner mod is there. That's not, we know that mod x is not differentiable at x equal to 0. We know that mod x is not differentiable at x equal to 0. Not differentiable at x equal to 0. And one more result, we know that mod of f of x is not differentiable at the points where f of x becomes 0, provided the function is continuous. Of course, the terms inside the mod is a polynomial function of degree 2 for x greater than 0 or x less than 0 in both the cases. For x greater than or equal to 0 or for x less than 0, terms inside the mod is a polynomial function of degree 2. We know that polynomial function of degree 2 is always continuous. Polynomial function itself is continuous everywhere. So I can tell that the function f of x is continuous everywhere. Nowhere it is discontinuous. So clearly I can tell m is what? M is the number of points where the function is not continuous. M is 0. Function is continuous everywhere. That's guaranteed. By looking at this, I can tell the function does not become discontinuous anywhere. Everywhere it is continuous. And I'm using this. Mod of f of x is not differentiable. Mod of f of x is not differentiable at the points where f of x becomes equal to 0. Okay? Not differentiable at the points where f of x becomes equal to 0. Mod of f of x is not differentiable at the points where f of x becomes equal to 0. Not differentiable at the points where f of x becomes 0, where f of x is a continuous function. So I'll discuss cases now, case 1 and case 2. Case 1, for x greater than or equal to 0. Case 1, if x is greater than or equal to 0. If x is greater than or equal to 0, I can use mod x as x, correct? Mod x becomes equal to x. My f of x becomes what? F of x becomes equal to mod of 2x square plus 5x minus 3, correct? Terms inside the mod equal to 0 to 2x square plus 5x minus 3 equal to 0. I am taking the points to find the points where the function is not differentiable. Terms inside the mod no equated to 0. I have written already, I am using this condition. Mod f of x is not differentiable at the points where f of x equal to 0. So mod of 2x square plus 5x minus 3 is not differentiable at the points where terms inside the mod is equal to 0. So if you factorize this, what do you get? 2x square, adding we should get 5, multiplying we should get minus 6. 6 minus 1 will do, correct? 2x is common. 2x is common, so what remains is x plus 3. Minus 1 common, x plus 3. Take x plus 3 common from this. X plus 3 into 2x minus 1 equal to 0. Correct? So this gives a into b 0 means either a equal to 0 or b equal to 0. X equal to half. X equal to minus 3 will reject because I am discussing the case where x is greater than or equal to 0. So this is rejected. This is accepted. X equal to half is accepted. X equal to minus half is rejected. Okay. So case 2. Case 2 is for x less than 0. Case 2 for x less than 0. If x is less than 0, what happens? If x is less than 0, mod x will be minus x, correct? Mod x becomes equal to minus x by definition of the differentiability. Definition of the modulus function. F of x equal to mod of 2x square minus 5x minus 3. Put mod x as minus x because for x less than 0, mod x is minus x. Terms inside the mod should be 0, correct? For non-differentiability, the function is not differentiable means terms inside the mod should be equal to 0. So factorize this. 2x square, adding we should get minus 5, multiplying we should get minus 6. Minus 6 plus 1 will do. Correct? Take 2x common. 2x common, 2x into x minus 3 plus 1 into x minus 3 equal to 0. Correct? X minus 3 is common from this. X minus 3 into 2x plus 1 equal to 0. This gives x equal to 3, x equal to minus half. X equal to 3, we shall reject this. X equal to 3 is rejected. I'll take x equal to minus half because I'm discussing the case x less than 0. X is negative. So this is rejected. This is positive value rejected. Take x equal to minus half. So I'm getting the points like x equal to half, minus half, and already x equal to 0 because the mod x is not differentiable at x equal to 0. 3 such points I'm getting where the function is not differentiable. So I can conclude that the function is not differentiable at exactly 3 points. N is equal to 3 and m equal to 0. M is the points where the function is not continuous. Function is continuous everywhere. And N is 3. Points are 0, minus half, plus half. Points of non-differentiability. Points of non-differentiability are x equal to 0, 1 by 2 and minus 1 by 2. At 3 points, the function is not differentiable. Okay. Therefore, M plus N is equal to 3. 0 plus 3 equal to 3. Answer is option D. Question asked on 1st of February, second shift, JEE Main 2024. Okay. So, modulus function is continuous everywhere. Polynomial function is continuous everywhere. So, number of points of discontinuity is 0. So, M is the points where the function is not continuous. Function is continuous everywhere. Everywhere the function is continuous. So, M equal to 0. And N is the points where the function is non-differentiable. I got 3 points. One is at x equal to 0. Another at x equal to half. Another I got x equal to minus half. Learn this result. Mod of f of x is not differentiable at the points where f of x becomes equal to 0. Provide the function f of x is continuous. Terms inside the mod is continuous, then terms inside the mod f of x is not differentiable. So mod of sin x is not differentiable at sin x equal to 0, x equal to n pi. Sin x equal to 0 means x equal to n pi. Mod of cos x is not differentiable where terms inside the mod is 0, cos x equal to 0. Cos x equal to 0 for x equal to 2n plus 1 pi by 2. It's a very standard result. Or else you can go by graphical method also. You can draw the graph and get the answer. X is positive, you draw the graph. X is negative, draw the graph. Okay. By graphical method also you can find out. By using the condition that where there is sharp point in the graph, no, where there is sharp point, at such point the function is not differentiable. If you want, you can draw the graph of this. The graph of this is something maybe something like this. At x equal to minus half, it's not differentiable. At x equal to half, it's not differentiable. At x equal to 0, the graph may be like this. Like this you may get. Like this you may get the graph of this function. Okay. At minus half, it touches the x-axis. Even at x equal to half also touches the x-axis. There is an intersection point, the sharp point at minus half and plus half. At 0 also there is the sharp point. So this is the graph you're going to get if you draw the graph by taking various cases. So non-differentiable points is 3. Okay. Hope it's clear. Move on to the next one. Question number 3. Consider the function f of x given like this. For x less than 3, one function, x greater than 3, another function, b for x equal to 3, where square bracket x denotes the greatest integer less than or equal to x. Capital S denotes the set of all ordered pairs a comma b such that f of x is continuous at x equal to 3. Then the number of elements in S is how much? How many such elements are there for which the f of x to become continuous at x equal to 3? So function is continuous at x equal to 3. So find out left hand limit, right hand limit, function value. Since f is continuous at x equal to 3, since f is continuous at x equal to 3, left hand limit equal to right hand limit equal to function value. Correct? Find out the left hand limit first. Left hand limit is limit x tends to 3 minus. Left hand limit. Find out. Limit x tends to 3 minus of this function. 3 minus means slightly less than 3. X less than 3. I have to use this function. Correct? A into 7x minus 12 minus x square. 7x minus 12 minus x square divided by b into mod of x square minus 7x minus x square minus 7x plus 12. This is left hand limit I need to find out. We can take one minus and common from the numerator. And x tends to 3 minus. We can factorize this x minus 3 into x minus 4, correct? I can factorize the terms inside the mod as x minus 3 into x minus 4. This is x minus 3 into x minus 4. X minus 3 into x minus 4. I can determine its sign. For 3 minus means slightly less than 3. So 2.99. 2.99 minus 3 is negative. 2.99 minus 4 also negative. Negative into negative is positive. So terms inside the mod is positive for x tends to 3 minus. So mod of x square minus 7x plus 12 becomes x square minus 7x plus 12. I repeat it once again. For x tends to 3 minus. 3 minus means slightly less than 3. So 2.99 you take. 2.99. 2.99 minus 3 is negative. 2.99 minus 4 also negative. Negative into negative is positive. So terms inside the mod is positive. So mod of x square minus 7x plus 12, I can write it as x square minus 7x plus 12 using the definition of modulus function, right? Using definition of modulus function, mod of x square minus 7x plus 12 becomes x square minus 7x plus 12 because terms inside the mod is positive. Applying definition of the modulus function. So I am getting limit x tends to 3 minus a into, you can take one minus sign common from the numerator. If you take minus 1 common, I will get x square minus 7x plus 12, correct? X square minus 7x plus 12. If you take a negative sign out from the numerator, negative terms will become positive. X square minus 7x plus 12. And denominator is what we have, b into mod of x square minus 7x plus 12 is same as x square minus 7x plus 12. Of which these two will cancel out. So left hand limit I am getting minus a divided by b. Left hand limit. Right hand limit you find out. Right hand limit is limit x tends to 3 plus. Limit x tends to 3 plus. What we have? 2 to the power sine of x minus 3 by x minus greatest integer function. Sine of x minus 3 divided by x minus greatest integer function. As x tends to 3 plus means slightly greater than 3, say 3.01. Greatest integer value of 3.01 becomes 3, correct? As x tends to 3 plus, what we have? Greatest integer value of x becomes equal to 3. So this is equal to limit x tends to 3 plus, 2 to the power sine of x minus 3 divided by x minus greatest integer value of x is 3, correct? As x tends to 3 plus sine of an angle by same angle is 1. As x tends to 3 plus x minus 3 is tending to 0, correct? So sine of an angle by same angle is 1. And both the angles in the numerator denominator is same, no? X minus 3 and it is approaching to 0, correct? Sine of an angle by same angle is 1. So this becomes 2 to the power 1. 2 to the power 1 is 2. As x tends to 3 plus, what we have? X minus 3 is approaching to 0 plus, correct? Limit x tends to 0 plus, we know, sine theta by theta is 1. Limit theta tends to 0 or 0 plus, whatever. In both the cases, we know, sine of an angle divided by same angle is equal to 1. First, to remove the greatest integer function. First, to evaluate the greatest integer function at the given point. As x tends to 3 plus, greatest integer function becomes 3. That's the first important thing. Whenever modulus function is there and greatest integer function is there, you need to simplify that at the given point. Okay. So right hand limit I got 2. And the function value at x equal to 3, the function value is b. Correct? F of 3 is equal to b. F of 3 is equal to b. Because the function is continuous at x equal to 3, left hand limit should be equal to right hand limit equal to function value. Since f is continuous at x equal to 3, this sentence was not required here. I'm writing it again still. Okay, left hand limit equal to right hand limit equal to function value. Left hand limit is equal to right hand limit is equal to function value. Left hand limit is how much? Minus a by b. Right hand limit is how much? 2. And the function value is b. Correct? So b is 2 I got. Equating the second and third, I'll get b is equal to, equating these two, I'll get b is equal to 2. And minus a is equal to 2b. Correct? Equating these two, I'll get minus a is equal to 2b. And b is equal to 2. So b is equal to 2, you can substitute here. 2 into 2 becomes 4. Minus a equal to 4 implies a equal to minus 4. A equal to minus 4 and b is equal to 2. Only one ordered pair I am getting, correct? So number of ordered pair is 1 they ask. Correct? Number of ordered pair is 1. Only one ordered pair I am getting where the function becomes continuous at x equal to 3. Therefore, ordered pair a comma b is minus 4 comma 2. That's the only one ordered pair. Only one ordered pair I'm getting. Only one ordered pair I'm getting for which the function is continuous at x equal to 3. Hope it's clear. Correct? cross multiply, a is equal to minus 2b or minus a equal to 2b, b is equal to, I got substitute there, minus a equal to 4, a equal to minus 4. How many ordered pairs are there? A comma b, for which the function is continuous at x equal to 3 hours. So only one ordered pair I am getting, option D. Question asked on 27th of January, first step, JEE Main 2024. Move on to the next one. Question number 4. Consider the function f of x, f from open interval 0, 2 mapped to R, defined by f of x equal to 2 by x plus x by 2, and the function g of x defined by this. Okay, we need to find out whether which of the options are given, which is one of them will be correct. Okay, so minimum of f of t, where t is between 0 and x including x, and 0 less than x less than or equal to 1. 3 by x plus x for x greater than 2. 3 by 2 plus x, I think this should be. This is 3 by 2 plus x, okay, small correction. 3 by 2 plus x. Function g of x is 3 by 2 plus x for x between 1 and 2. Need to check whether the function is continuous or not. At x equal to 1, at x equal to 2, okay. Now, at x equal to, the doubtful point is x equal to 1. So we have to find minimum of f of t for t between 0 and x. F of x is given as 2 by x plus x by 2. Find the minimum value of this function. I'll find out whether the function is increasing or decreasing, because minimum of f of t I had to consider for t between 0 and x including x, and x is between 0 to 1. It's a quite different type of question, but it's a typical JEE Main level question. Many times questions are asked based on this type of minimum of f of t. So I'll use the concept of increasing and decreasing function first. I'll see the nature of the function f of x in the interval 0 to 2. What is happening for the function f of x? Okay, it's defined as 2 by x plus x by 2. F of x is 2 by x plus x by 2. X by 2 plus 2 by x. Differentiate this. But actually we know this is very standard result actually. F of x equal to a by x plus x by a. Now will be decreasing in the interval minus a to 0 union 0 to a. I know this result, but still I am doing it for your benefit. Okay. So function f of x, if you want to write here directly, f of x equal to x by a plus a by x, if you consider x by a plus a by x is going to be strictly increasing. It's going to be strictly increasing in the interval minus infinity to a, okay, minus infinity to a, minus a union a to infinity. In this interval the function is strictly increasing, minus infinity to minus a union a to infinity, and the function will be strictly decreasing. The function will be strictly decreasing in the interval minus a to 0 union 0 to a. Minus a to 0 union 0 to a. So this function is going to be strictly decreasing in the interval minus 2 to 0 union 0 to 2. Using this I can tell directly. If you want, I can do the method also. F of x 2 by x plus x by 2 by x means 2 into 1 by x. X by 2 means half into x. F dash of x. F dash of x will be derivative of 2 into 1 by x. 2 into minus 1 by x square. 2 into minus 1 by x square. Constant into variable. Constant keep as derivative of x1. Correct? Function is decreasing. Function is decreasing means what? F dash of x less than 0. Correct? I can see the nature of the function. F dash of x less than 0 implies what will get? 1 by 2 minus 2 by x square is going to be less than 0. That means 1 by 2 is going to be less than 2 by x square. That means x square is less than 4 I'll get. X square is less than 4 means x is lying between minus 2 and plus 2. Okay. But x not equal to 0. But x is not equal to 0. Therefore, the function f of x, this function f of x is strictly decreasing. F is, because I use the condition f dash of x less than 0, the function is strictly decreasing. F is strictly decreasing in the interval minus 2 to 0, 0 to 2. Minus 2 to 0, union 0 to 2. Already I wrote the shortcut. You can, not the shortcut, I can use the word as time saving result. Okay, it's a time saving result. X by a plus a by x is a function strictly decreasing in the interval minus a to 0, union 0 to a. That's what I got. You can remember this as a result. It's a time-saving result because it's a very frequent use. Many times it has appeared in various competitive exams, so you can remember it. And so the function in the interval 0 to 2 is going to be strictly decreasing, correct? You can see this interval 0 to 2 is here, correct? 0 to 2, in that interval the function is strictly decreasing. Strictly decreasing means as you increase the value of x, the function value is going to decrease, the decreasing function. So minimum of f of t, if the function is decreasing in the interval 0 to 2, 0 to 2 the function is decreasing, right? So the minimum value will occur when it is closer towards 2, correct? Anyway, the interval is open, right? I can't include the 2. 2 is excluded here. So where it is occurring, the minimum value closer towards 2. So I'll take it as x. Okay. So in this entire interval 0 to the function is decreasing only. So minimum value occurs at x very close to 2, x tends to 2. So minimum of f of t is nothing but f of x only. I'll take this function f of x. No need to break this interval 0 to 2. In the entire interval 0 to 2, the function is decreasing only. In the interval 0 to 1 also the function is decreasing only, correct? So 0 to 1, minimum of f of t is going to be nothing but f of x. I'll use this function f of x itself as minimum of f of t, okay? F of x is 2 by x plus x by 2, means f of t is going to be 2 by t plus t by 2. So minimum of f of t is nothing but f of x. I'll use f of x for the first line, because my interval x lies between 0 and 1, including 1, correct? So I'll split, I'll use minimum of f of t as 2 by x plus x by 2, because the function is going to be decreasing in the entire interval 0 to 2. In the interval 0 to 1 also the function is decreasing. And if you put x equal to 1, you'll get the minimum value if you take this interval. So g of x becomes equal to what? G of x is equal to minimum of f of t, that is nothing but at t equal to x, that is 2 by x plus x by 2. 2 by x plus x by 2. This is for 0 less than x less than or equal to 1. And the second line is given 3 by 2 plus x. 3 by 2 plus x. This is for x between 1 and 2. The only doubtful point is at x equal to 1. Correct? At x equal to 1 is a doubtful point. So at x equal to 1, you need to check the continuity of the function. Outside the x equal to 1, check the differentiability of the function, because various options are given, no, in terms of continuity and differentiability. So at x equal to 1, you find out whether the left hand limit is equal to right hand limit. At x equal to 1, left hand limit is how much? Limit x tends to 1 minus. Limit x tends to 1 minus. 1 minus means x less than 1. I have to use this. 2 by 1 plus 1 by 2. Correct? Limit x tends to 1 minus. Limit x tends to 1 minus of the function 2 by x plus x by 2, that is going to be equal to 2 by 1 plus 1 by 2, 2 plus half, that is 5 by 2. At x equal to 1, even the function value at x equal to 1, how much? 2 by 1 plus 1 by 2, that is also same, 5 by 2 only. Right hand limit you find out. Right hand limit is limit x tends to 1 plus. Limit x tends to 1 plus. 1 plus means x greater than 1. That is 3 by 2 plus x. 3 by 2 plus x. Which is equal to 3 by 2 plus 1. That is equal to 5 by 2. Correct? Left hand limit is equal to right hand limit equal to function value. Everything is same. Therefore, the function is continuous at x equal to 1. LHL is equal to RHL is equal to function value. Therefore, f is continuous at x equal to 1. What about the differentiability? You can conclude that f is continuous at x equal to 1. What about the differentiability at x equal to 1? The differentiate g dash of x. F, no, not f, g, correct? My function is g. G is continuous, I should write. G is continuous at x equal to 1. Now, at x equal to 1, we need to find the g dash of x. G dash of x is equal to how much? Derivative of 2 by x is minus 2 by x square, correct? Minus 2 by x square. Derivative of x by 2 is 1 by 2. This is for x between 0 and 1. Next one, derivative of 3 by 2 is 0. Derivative of x1. This is for x between 1 and 2. G dash of 1 minus how much? For x less than 1. that is minus 2 by 1 square, minus 2 plus half, correct? Minus 2 by 1 plus half, which is equal to minus 3 by 2. And g dash of 1 plus, g dash of 1 plus is 1. They are not equal. See, left hand derivative is not equal to right hand derivative. The function is not differentiable at x equal to 1. G dash of 1 minus is not equal to g dash of 1 plus. Therefore, g is not differentiable at x equal to 1. G is not differentiable at x equal to 1. So, function is continuous but not differentiable at x equal to 1. That's the answer. Option E. Question asked on 27th of January, second shift, JEE Main 2024. Hope it's clear. Important thing is finding the nature of this function f, and you can substitute here. This function f is strictly decreasing in the interval 0 to 2. Not only decreasing in the interval 0 to 2, minus 2 to 0 and 0 to 2. The function is decreasing. So we want only in the interval 0 to 2. This function is strictly decreasing. If you draw the graph will come like this. X by 2 plus 2 by x. As x value increases in the interval 0 to 2, the function value decreases. So at x equal to 1, the function will have minimum value in the interval 0 to 1, I can tell. Okay? Because x value increases, function value decreases. Minimum value occurs when x equal to 1. So for x between 0 and 1, minimum of f of t is, that is written as x by 2 plus 2 by x. If you want at x equal to 1, the minimum value occurs, I can tell, for this function in the interval 0 to 1, because the function is strictly decreasing in the interval 0 to 2. I am using f of x as a minimum of f of t is nothing but f of x. If there was any variation, suppose the function was in the interval 0 to half it is decreasing and half to 1 it is increasing, then I need to use different cases here. But now it's not required. Okay. So now in this entire interval the function is decreasing only. I am using this function, minimum of f of t, which is f of x. Okay. Hope it's clear. Move on to the next one. Question number 5. Function f of x given like this is differentiable on R. Find 48 times a plus b. So mod x greater than or equal to z, mod x less than 2 z. We need to find 48 times a plus b. F of x is given like this. We can rewrite this as f of x equal to, it's a numerical type question, x mod x greater than or equal to. Mod x greater than or equal to means x is greater than or equal to, or x is less than or equal to minus 2. For x greater than or equal to, x is positive, right? So 1 by mod x will be 1 by x. 1 by x. And for x less than or equal to minus 2, that means x value is negative. X value negative means mod x becomes minus x, so it becomes minus 1 by x. Now x mod x less than 2 means x lies between minus 2 and plus 2. That is ax square plus 2b. Ax square plus 2b. Like this you can write. Okay. Mod x less than 2 means x lies between minus 2 and plus 2. Learn the rules of inequalities. Mod x less than a. A is positive real number. Mod x less than a means x lies between minus a and plus a. Okay. Mod x greater than or equal to a means x is greater than or equal to a, or x is less than or equal to minus a. Learn the rules of inequalities properly. Okay. Where a is some positive real number. Where a is some positive real number. Okay. So we need to check, we need to find the values of a and b. Given that the function is differentiable, we know that every differentiable function is continuous, correct? So every differentiable function is continuous. Using that, I am going to find the constants a and b. I use continuity at x equal to 2, and also I use differentiability at x equal to 2. Even at minus 2 also I can use. 1 point is enough for me. Using continuity at x equal to, f is continuous at x equal to, f is continuous at x equal to implies left hand limit equal to right hand limit equal to function value. Limit x tends to 2 minus. 2 minus means value of x is less than 2. X less than 2 is this, ax square plus 2b. Ax square plus 2b. Limit x tends to 2 minus is equal to limit x tends to 2 plus. 2 plus means x greater than 2, that is 1 by x, is equal to f of 2. Correct? X tends to 2 minus f of x. Limit x tends to 2 plus f of x equal to f of 2. 2 minus means put x equal to 2. Don't put minus 2. 2 minus is meaning is left hand limit, indication of left hand limit. 2 minus is indication of left hand limit, not to put x equal to minus 2. Value of x is approaching 2 from the left side, slightly less than 2. That's the meaning of 2 minus. Put x equal to 2 square is 4. 4a plus 2b is equal to x equal to, you can put 1 by 2. Or else you can divide the entire equation by 2 from this. You can write this as 2a plus b equal to 1 by 4. Dividing by 2 and get 2a plus b equal to 1 by 4, equation 1. Using continuity at x equal to, I am getting this. Left hand limit, x less than 2 is left hand limit. X greater than 2 is right hand limit. Okay, I am using continuity at x equal to. Also, I need to find the derivative here. F dash of x will find out. F dash of x. Derivative of 1 by x is minus 1 by x square. This is for x greater than or equal to. Derivative of minus 1 by x is plus 1 by x square. This is for x less than or equal to minus 2. Derivative of ax square, that is a into 2x, 2ax. Derivative of b is 0. This is for x between minus 2 and plus 2. Now f dash of 2 minus, because the function is differentiable, I'll use the condition that f dash of 2 minus equal to f dash of 2 plus. F dash of 2 minus means what? X less than 2. X less than 2 is 2 minus. Derivative is 2ax. Put x equal to 2 and write 2a into 2 becomes 4a. F dash of 2 plus, for x greater than 2, derivative is minus 1 by x square. Put x equal to minus 1 by 2 square, minus 1 by 4. So we get a is equal to how much? Minus 1 by 16. Correct? 4 comes down. A is minus 1 by 16. So a got, b you can find out. This is called equation 2. So b is equal to how much? From equation 1. From 1 I am going to get, from equation 1, b is how much? B is equal to 1 by 4 minus 2a. Correct? 1 by 4 minus 2 into a we got minus 1 by 16. So this will be equal to how much? 1 by 4 minus into minus plus 2 by 16 is 1 by 8. Take common denominator 8. 4 2s are, so 2 plus 1 divided by 3 by 8 I am getting. I need to find 48 times a plus b. Required is 48 times a plus b. 48 into value of a, how much we got? Value of a we got here minus 1 by 16. Value of a is minus 1 by 16. Value of b how much? 3 by 8. 48 into minus 1 by 16 is minus 3. 48 into 3 by 8, how much? 8 ones are 8 6 are 6 3s are 18 I am getting. So minus 3 plus 18, which is equal to 15. So numerical type question asked on 30th of January, first shift, JEE Main 2024. Answer is 15. Using the concept that every differentiable function is continuous, I am getting it. Use continuity at x equal to left hand limit equal to right hand limit equal to function value. Use differentiability, left hand derivative equal to right hand derivative. I use only one point here at x equal to only. I not used x equal to minus 2. If you want, you can use at x equal to minus 2 also. You get the same answer. Okay. X equal to minus 2, you can use the continuity and differentiability. I use only x equal to. First you learn this basic concept. Mod x less than a means x lies between minus a and plus a. Okay. The basic concept you must learn. Mod x less than 2 means x lies between minus 2 and plus 2 using this. And mod x greater than or equal to means x is greater than or equal to, or x is less than or equal to minus 2. Okay, just use this and get the answer. Hope it's clear. Please go through it. On to the next one. Question number 6. Let a and b be real constants such that the function f defined by this is differentiable or not. Again, I am using, to find the constants a and b, I need two equations. To get two equations, I will use continuity at x equal to 1. I will use differentiability at x equal to 1. Function is differentiable on the entire real number 9. In particular, it's also differentiable at x equal to 1. And we know that every differentiable function is continuous. Correct? So use continuity at x equal to 1, use differentiability at x equal to 1. Key concept is every differentiable function is continuous. You must know that every differentiable function is continuous. 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 This is a result I am going to use. Because the function is differentiable everywhere on the real number line, function is also continuous everywhere. In particular, using continuity at x equal to 1 and differentiability at x equal to 1. I'll use those two conditions and get two equations and get the values of a and b. So we'll get the values of a and b, then I can integrate from -2 to +2 f of x dx equal to how much? Correct? So now we'll use f is continuous at x equal to 1. Now f is continuous at x equal to 1. F is continuous at x equal to 1. Left hand limit should be equal to right hand limit equal to function value. For x less than 1, x less than 1 is first line, correct? X bar plus 3x plus a. I'll use the first line for left hand limit. X greater than 1 is for right hand limit. So one equation we get. F is continuous at x equal to 1 implies limit x tends to 1 minus. Limit x tends to 1 minus. 1 minus means slightly less than 1. X less than 1. Left side of 1. So x less than 1, I got this. X square plus 3x plus a. X square plus 3x plus a is equal to limit x tends to 1 plus. Limit x tends to 1 plus. 1 plus means x greater than 1. That is bx plus 2. Correct? Bx plus 2. Left hand limit equal to right hand limit is equal to function value. F of 1 I'll keep as it is. That's not required for me. Two of them enough to get the relation between a and b. Put x equal to 1. 1 square is 1 plus 3 into 1 plus a. Limit x tends to 1 plus b into 1 plus 2. Correct? From this, what we get? A plus 4 is equal to b plus 2. So from this, I'll get the condition that a minus b is equal to 2 minus 4, which is minus 2. Equation 1. Correct? Putting x equal to 1. 1 minus means it's an indication of left hand limit. Just put x equal to 1. 1 square plus 3 into 1 plus a. So a plus 4 equal to b into 1 plus 2. B plus 2. A minus b equal to 2 minus 4 minus 2. Now use differentiability at x equal to 1. Find f dash of x there. F dash of x. Differentiate and write. F dash of x is equal. Derivative of x square is 2x. Derivative of 3x is 3. This is for x less than or equal to 1. Derivative of bx is b and derivative of 2 is 0. This is for x greater than 1. Correct? Now find out. At x equal to 1, the left hand derivative should be equal to right hand derivative. Since f is differentiable at x equal to 1, since f is differentiable at x equal to 1, f dash of 1 minus should be equal to f dash of 1 plus. F is differentiable at x equal to 1. What we have? F dash of 1 minus is equal to f dash of 1 plus. F dash of 1 minus means what? X less than 1. What's the derivative we got? 2x plus 3. Put x equal to 1 and write here. Put x equal to 1. 2 into 1, 2 plus 3. Correct? Is equal to right hand derivative. That is x greater than 1. What is the derivative we got? B. So f dash of 1 plus is b. Therefore b is equal to 5. B is equal to 5. I got. I can find the value of a from equation 1. B is equal to 5. This is called equation 2. So from 1, a is equal to b minus 2. Correct? From equation 1, what we have? A is equal to, A is b minus 2. Correct? B minus 2. B is already we got 5. So 5 minus 2 is equal to 3. A we got, B we got. Now I can substitute the values of A and B there. And I can integrate from minus 2 to plus 2. My splitting property I use there. Integral from A to B is A to C plus C to B, where C lies between A and B, correct? So I'll split it at x equal to 1 and split. Because for x less than 1, one function. X greater than 1, another function, correct? So f of x we can write after getting the values of A and B now. After getting the values of A and B, my f of x becomes, f of x is equal to x square plus 3x plus 3. x square plus 3x plus 3. This is for x less than or equal to 1. And b we got how much? 5. 5x plus 2. 5x plus 2. This is for x greater than 1. This is my function f of x. I need to integrate from minus 2 to plus 2 of this function f of x. Therefore, integral from minus 2 to plus 2. Integral from minus 2 to plus 2 f of x dx. I split this integral at x equal to 1. Minus 2 to 1. Minus 2 to 1 means the value of x is less than 1. For x less than or equal to 1, I can use this. X square plus 3x plus 3. Correct? The first line. And for x greater than 1, my function is 5x plus 2. So integrate from 1 to 2, 5x plus 2. Integrate this and get the answer. Integral of x square is x cube divided by 3. Integral of 3x is 3x square by 2. Integral of 3 is 3x. This is limits from minus 2 to 1. Integral of 5x is 5x square by 2. Integral of 2 is 2x. Evaluate the function at upper limit minus lower limit and get the answer. So what we get? This will be equal to 1 by 3 into upper limit minus lower limit. 1 cube is 1. Minus 2 cube is minus 8. 1 minus minus 8 becomes 1 plus 8. Correct? Evaluate the function at upper limit minus lower limit. 1 cube is 1. 1 minus minus 2 cube. Minus 2 cube is minus 8. Here 3 by 2 into 1 square is 1 minus minus 2 square. So 1 minus 4. Here 3 into 1 minus minus 2. Next, here 5 by 2 into 2 square minus 1 square. 4 minus 1, 3. Plus 2 into 2 minus 1, which is 1. Correct? So what we get here, 9 by 3 is going to be equal to 3. Simplify it and write the answer. This is equal to 3 plus, this is 1 minus 4 is minus 3. Minus 3 into 3. Minus 9 by 2. Minus 9 by 2. Correct? 3 into 3 becomes 9. Plus 5 into 3, 15 divided by 2 plus 2 is equal to how much? Calculate. 9 plus 2 is 11. 11 plus 3 is 14. And 15 by 2 minus 9 by 2. That is 6 by 2, 3. 3 plus 14. Answer is 17. Correct? 3 plus 9, 12. 12 plus 2 is 14. 15 by 2 minus 9 by 2. 6 by 2. That is 3. 14 plus 3. Answer is 17. So option D is answered. Question asked on 30th of January, second shift, JEE Main 2024. Okay, just use the concept of continuity and differentiability because every differentiable function is continuous. Given that the function is differentiable, implies the function is also continuous. Differentiability is the stronger condition than continuity. So every differentiable function is continuous. Every continuous function need not be differentiable. Okay, and every discontinuous function is non-differentiable. You must know this. Every differentiable function is always continuous. Every continuous function may be differentiable or might not be differentiable. No, we don't know about that. No guarantee can be given about the differentiability. The function is continuous, it need not be differentiable. And every discontinuous function is always non-differentiable function. Whichever function is discontinuous, it is not differentiable. Okay, 3 things you must know. But here I am using differentiability implies continuity. Okay, even in the previous question also we use the same concept. Differentiability implies continuity. This was a condition. Every differentiable function is continuous in this question and this question. So I have written here, important point here. Every differentiable function is continuous. Use continuity at x equal to 1. Left hand limit equal to right hand limit equal to function value. Use differentiability at x equal to 1. Left hand derivative equal to right hand derivative. We'll get the values of a and b. A we got 3 and b we got 5. Substitute and integrate. Integral from minus 2 to plus 2 at a split at x equal to 1 because for x less than or equal to 1 a function is given, one function, and x greater than 1 another function. So split at x equal to 1 and integrate and get the answer. Hope it's clear. Move on to the next one. Question number 7. This is a question based on the functional equation f of x by y is equal to f of x divided by f of y for all x comma y, f of y not equal to 0. So given f of x by y is equal to f of x by y is equal to f of x divided by f of y. F of x divided by f of y, where f of y is not equal to 0. This condition is satisfied for which function you can identify easily. This is satisfied for f of x equal to x power n. If you want, you can find out. F of x by y will be what? X by y power n. X by y power n is x power n by y power n, which is f of x by f of y, correct? If you want to show, if you take f of x as x power n, what is f of x by y? F of x by y is going to be equal to, replace x by y. We'll get x by y whole to the power n. X by y whole power n is x power n divided by y power n, which is f of x divided by f of y, for f of y not equal to 0. Okay, it's a question based on the functional equation. Many such functional equations are there that you can note down. I'll do it in the synopsis of this, and also many times we discuss this kind of question, functional equation type of. And f dash of 1 is given to be equal to 2024. Which of the option is going to satisfy? So f dash of x is equal to how much? F dash of x is equal to n into x power n minus 1. In various competitive exam, these kind of questions are very common. Okay, even in NDA exam also, this kind of question was asked in the year 2024. F dash of x is given to be equal to 2024. F dash of 1 is given. Correct? F dash of 1 how much? F dash of 1 is, put x equal to 1, n into 1 to the power n minus 1. 1 to the power, any number is 1, 1 into n is n. So n is, f dash of 1 is given to be equal to 2024, correct? This was given in the question. So my n becomes equal to 2024. So f of x will be x power 2024. F dash of 1 is given to be equal to 2024. Using that, I got the value of n as 2024. My f of x becomes what? Therefore, my f of x will be x power 2024. F of x becomes x power 2024. Now, I need to verify which of the option is satisfied. You can find the derivative here. F dash of x is equal to how much? F dash of x is derivative of x power 2024 is 2024 into x power 2023. F dash of x we got. If you find out x into f dash of x, that will be same as 2024 f of x, correct? X into f dash of x is equal to how much? Multiply by x on both sides. 2024 into x power 2024. That is 2024 into x power 2024 is f of x, right? So 2024 into f of x. So I'm getting x into f dash of x equal to 2024 f of x. That means the first option is satisfied, correct? Therefore, I can write this as x into f dash of x, x into f dash of x minus 2024 into f of x is equal to 0. Answer is option A. Option A is satisfied, correct? X into f dash of x minus 2024 into f of x equal to 0. Option A is satisfied. So, it's a question based on the functional equation. F of x by y is equal to f of x by f of y, satisfied for f of x equal to x power n. I'll write some of the functional equations here. Functional equation, and the function is which is going to satisfy. Functional equation. And which function is going to satisfy? I'm going to list out here. See, f of xy is equal to f of x into f of y. F of xy is equal to f of x into f of y. Or if it is f of x by y is equal to f of x divided by f of y for x not equal to y. Okay, for f of y not equal to 0. Denominator is not equal to 0. Both of this are satisfied for f of x equal to x power n. Must know this. Okay, this is the first one. And the second one, suppose I give f of xy is equal to f of x plus f of y. Here log x is going to satisfy. F of xy is equal to f of x plus f of y, satisfied for f of x equal to log x. Because log of xy is log x plus log y. Correct? F of x plus y is equal to f of x into f of y. That is satisfied for e power x or a power x. Correct? This is satisfied for f of x equal to a power x or e power x, e power x or a power x, or even I can write e power kx, correct? E power kx or a power kx, a power k into x plus y, a power kx into a power, like that. So like that many other, f of x into f of 1 by x, f of x, if it's a polynomial function of degree n, I can write f of x into f of 1 by x equal to f of x plus f of 1 by x. This is satisfied for f of x equal to 1 plus or minus x power n. 1 plus or minus x power n. And one more I can write it for e power x log x, and f of x plus y is equal to f of x into f of y. I can write f of x plus y is equal to f of x plus f of y. This is satisfied for f of x equal to kx, where k is some real number. Okay, please note down this functional equations I have written. K into x plus y is kx plus ky. And one more I can add here, if it is like this, f of x plus y is equal to f of x plus y is equal to f of x plus f of y, f of x plus f of y minus some constant k. In that case, f of x will be equal to ax plus b. Linear function is going to satisfy ax plus b. Okay, f of x plus y is equal to f of x plus f of y minus k. Then f of x is ax plus b. Linear function is going to satisfy. So answer is option A here. I have given additional information about the functional equations on this. Okay, move on to the next one. Question number 8. G of x is a linear function and f of x is given like this. The continuous at x equal to 0. F dash of 1 equal to f of minus 1. The value g of 3 is how much? Then the value g of 3 is how much you have to find out. Take g of x as linear function. They told g of x a linear function. No? Let g of x be equal to ax plus b. Let g of x be equal to ax plus b. A and b are real numbers. Okay, a and b are real numbers. It's understood. Where a and b are real numbers. Okay. So f of x is continuous at x equal to 0. Function is continuous means use left hand limit equal to right hand limit equal to function value. So left hand limit at x equal to 0. F is continuous at x equal to 0. F is continuous at x equal to 0 implies left hand limit is equal to right hand limit equal to function value. Correct? Left hand limit is equal to right hand limit is equal to function value. Start. Find out left hand limit now. Left hand limit is how much? Left hand limit is limit x tends to 0 minus. Correct? X tends to 0 minus. For 0 minus, my function is the linear function g of x. G of x is ax plus b. Put x equal to 0 and write a into 0. 0 plus b is equal to b. Now find out right hand limit. Right hand limit. Limit x tends to 0 plus. Limit x tends to 0 plus. 0 plus means x greater than 0. 1 plus x by 2 plus x to the power 1 by x. 1 plus x divided by 2 plus x whole to the power 1 by x. If you apply limit here, this becomes how much? 1 plus 0 by 2 plus 0, that is half. Half to the power 1 by 0. 1 by 0 is infinity. Half to the power infinity, that is equal to 0. Correct? If a number lies between 0 and 1, to the power infinity is 0. We know this because I'll write the reason here. Limit n tends to infinity, r to the power n is 0. Limit n tends to infinity, r to the power n is 0. If r lies between 0 and 1, using this concept. Okay? When you apply limit, the base is becoming half and the power is becoming infinity. Half to the power infinity is 0. Because we have this concept. As n tends to infinity, r power n is 0 if r lies between 0 and 1. Half is a number between 0 and 1. So half to the power infinity is 0. Half square 1 by 4. Half cube 1 by 8. Half to the power 10 becomes 1 by 1024. So as n tends to infinity, the expression tends to 0. Correct? This is tending to 0 as n tends to infinity because the power is tending to infinity. Correct? Power is n here. R power n is 0 as n tends to infinity. So half to the power infinity is 0. The power is becoming large and the base is a number between 0 and 1. Half to the power infinity is 0. So right hand limit is 0. Okay. Even the function value is also b itself. Correct. Even f of 0 is equal to b. Using star. From star it follows that. From star it follows that what? Left hand limit how much we got? B. Correct. Left hand limit is b. Right hand limit is 0. Correct. Even the function value is 0. F of 0 how much? F of 0 is b only, correct? F of 0. F of 0 means g of 0. G of 0 is b. So b is equal to 0 I'm getting. Okay? B is equal to 1. Equation 1. That will be. B is equal to 0. So value of b is 0. Therefore my function g of x becomes a into x plus b is 0. Only ax remains. I need to find the value of a now. So to find the value of a, what we can do is I can find out f dash of, I can use this condition, f dash of 1 equal to f of minus 1. Minus 1 is a number which is less than 0, right? So I can use f of minus 1 as g of minus 1, correct? f of minus 1. Now f of minus 1 is going to be equal to f of minus 1 is going to be equal to what? G of minus 1, because for x less than or equal to 0, f of x is g of x. So f of minus 1 will be g of minus 1. G of minus 1 is going to be equal to a into minus 1. A into minus 1, correct? G of x is here, ax plus b. A into minus 1 plus b, b is 0, correct? So what I am getting is minus a. G of f of minus 1 is minus a. F dash of 1 I have to find out. F of x, 1 is a number which is greater than 0. So I have to use this function. For greater than 0, I have to use this function. 1 plus x by 2 plus x to the power 1 x. I need to differentiate that and put x equal to 1. F dash of 1 I want, correct? So to find f dash of x, I use logarithmic differentiation, because this is variable for variable. Variable for variable means I use log and differentiate. Otherwise, I can use the formula derivative of u power v. Derivative of u power v is u power v into derivative of v log u, using that. Okay. So to find f dash of x, I am using this formula. D by dx of u power v. D by dx of u power v is equal to what? U power v into d by dx of v log u. D by dx of v log u, using this. Okay. F of x is what? 1 plus x by 2 plus x to the power 1 by x. F of x is equal to 1 plus x divided by 2 plus x whole to the power 1 by x. This implies f dash of x is equal to, using this formula, derivative of u power v is u power v into derivative of v log u. Same thing you write. What is the same thing you write? Into derivative of v log u. Bring the power down, take log for the base and write. F dash of x will be what? 1 plus x by 2 plus x. 1 plus x divided by 2 plus x to the power 1 by x into d by dx of v log u. Bring the power down. 1 by x into log of 1 plus x by 2 plus x, which you can write as log of 1 plus x minus of log of 2 plus x. So that differentiating becomes easy if you take like this, using property of log simultaneously. Log a by b is log a minus log b. So this will be equal to how much? 1 plus x by 2 plus x, 1 plus x by 2 plus x to the power 1 by x, correct? Into 1 by x into here, derivative of log 1 plus x, 1 by 1 plus x into derivative of 1 plus x is 1, minus 1 by 2 plus x into derivative of 2 plus x is 1, correct? First into derivative of second plus second into derivative of first. The derivative of 1 by x is minus 1 by x square. I will write this as log 1 plus x by 2 plus x. I am not differentiating, no. I am keeping the second function as it is. So I will keep this in the form of log a by b, because log a minus log b is log a by b. So this will be log of 1 plus x by 2 plus x, 1 plus x by 2 plus x into derivative of 1 by x. Derivative of 1 by x is minus 1 by x square. Minus 1 by x square, like this. Now we need to find f dash of 1, correct? Because I have given the condition that f dash of 1 equal to f of minus 1. So now f dash of 1 equal to f of minus 1 implies f dash of 1 is equal to f of minus 1, using this condition. F dash of 1 means I need to put x equal to 1 in this. 1 plus 1, 2. 2 plus 1, 3. This becomes 2 by 3. 2 by 3 to the power 1 by 1, correct? Putting x equal to 1 in this. What I am getting? 2 by 3. 2 by 3 outside the bracket, it is into here 1 by 1 is 1, correct? 1 by 1 into 1 by 1 plus 1 minus 1 by 2 plus 1, correct? Log of, this is plus into minus is minus, 1 by 1 square is 1, this becomes log of 2 by 3 when you put x equal to 1. So minus log 2 by 3, minus log 2 by 3 I am getting. Minus log 2 by 3. F of minus 1. F of minus 1 is put x equal to f of minus 1 already we got. G of minus 1. Here I wrote. F of minus 1 is g of minus 1, which is equal to minus c. So minus c. Correct? So I can find the value of a from this. Correct? Once we get the value of a, then I can find out g of 3. G of 3. B already we got, no, B is 0. One constant we got here, B is equal to 0. I am trying to find another constant now. So from this, what we get? 2 by 3 into, here, 2 entry LCM is 6. 2 3s are, so 3 2s are, minus log 2 by 3 is equal to minus A. Correct? 3 minus 2 becomes 1 there. Correct? 3 by 6 half, 2 by 6, 1 by 3. So 2 1s are 2 3s are, becomes 1 by 9 there. Correct? 1 by 9 minus 2 by 3 log 2 by 3, which is equal to minus A. Correct? I need to find G of 3. G of 3 means I need to find G of 3 same as F of 3. Correct? G of 3 is required. Want to find the value of G of 3. G of x is how much? G of x is here, ax plus b. Correct? From there I have to find G of 3. G of 3 is required. So now you can multiply by minus 1 and then substitute there. Okay? G of 3 is required is G of 3. Required is G of 3. G of 3 is equal to A into 3 plus B. Correct? A into 3 plus B. B already we got 0. A I am getting like this. You can multiply by minus 1 and substitute here. Okay? So 3 into A is equal to how much? A will be negative of this. Multiply by minus 1. I'll get this will become A. Correct? When you multiply by minus 1, you get the value of A. So 2 by 3 into log 2 by 3 minus 1 by 9. 2 by 3 into log 2 by 3. Sorry, don't close the bracket there. Minus 1 by 9. A, I am substituting the value. 3 I kept outside. A is how much? 2 by 3 log 2 by 3 minus 1 by 9. Plus value of B is 0. Correct? B we got 0. Now multiply this 3 inside. What we get? 3 3 cancels. I get 2 log 2 by 3 minus 1 by 3. Correct? I'll write here the remaining part. Therefore, G of 3 is equal to, I am getting this as 2 into log 2 by 3 minus 1 by 3. 2 log 2 by 3 is log of 2 by 3 square becomes log 4 by 9. Correct? Using the property n log m is log m power n. 2 goes to the power. Log 2 by 3 square. 2 by 3 square is 4 by 9 minus 1 by 3. Minus 1 by 3. I can write this in terms of log of 4 by 9 e power 1 by 3. Because 1 by 3, no, I can absorb inside the log in terms of e power. So that becomes log of 4 by 9 log of 4 divided by 9 into e power 1 by 3. Because log e power 1 by 3 is nothing but 1 by 3. Correct? The denominator is there, so minus sign. So answer is option D. Hope it's clear. If you want, you can write one step extra here. One by 3 could be written as 1 by 3 is log of e power 1 by 3. Okay. The base is e here. Log e power 1 by 3 is nothing but 1 by 3. So 1 by 3 is log e power 1 by 3. Is that clear? So this becomes log 4 by 9. Log 4 by 9 minus log e power 1 by 3. Log e power 1 by 3 is 1 by 3. Log a minus log b. Log a by b. This becomes log a minus log b. Log a by b. So log 4 by 9 divided by e cube, which is log of 4 by 9 e power 1 by 3. Log e power 1 by 3, log a minus log b. Log of a by b. Log of 4 by 9 divided by e power 1 by 3. That is this. Correct? Using log a minus log b. Log of a by b. This comes to denominator. With 9 gets multiplied. Answer is option D. Hope it's clear. Question asked on 31st of January, first shift 2024 JEE main. Quite a simple question. Take a g of x as a linear function and go on doing it. Apply the definition of continuity at x equal to 0. You'll get one constant b. Also the concept of limit is used here. R to the power n is equal to 0 as n tends to infinity if r lies between 0 and 1. Limit concept is also used here to get the value of b. Then use f of minus 1 same as g of minus 1. Also derivative concept is required here. Derivative of u power v is u power v into derivative of v log u. Okay. Move on to the next one. Consider the function f from open interval 0 to infinity mapped to R defined by f of x equal to e power minus mod of log x. M and n are respectively the number of points at which the function is not continuous and not differentiable. Find m plus n. So rewrite this function using the definition of modulus function, where log function is positive and where log function negative, you must know. So mod of log x is it. You must know that log x is positive. Log x base e is going to be positive if x is greater than 1. Okay. And log x to the base e is going to be negative if x lies between 0 and 1. You must know this. If x lies between 0 and 1, log x is negative. Log of a number between 0 and 1 is negative. Log of a number greater than 1 is going to be positive. The number is greater than 1, then log value is positive. The number lies between 0 and 1, log function is negative. And log x becomes 0 at x equal to 1. Log x base e becomes equal to 0 if x is equal to 1. You must know these three things about the log function. First point, second point, and the third point. Three things you must know first. Okay. The function f of x given e power minus mod of log x. So whenever there is modulus function and you need to split where it is positive and where it is negative, you must know. So log x is positive for x greater than 1. Log x is negative for x between 0 and 1. Split at x equal to 1. Rewrite this function. Okay. The function f of x could be written as e power minus mod of log x will be log x. If x is greater than 1, correct? So mod of log x becomes log x base e. This is if x is greater than or equal to 1, right? Log 1 is anyway 0, equal to 1 also include that. And if x is between 0 and 1, if x lies between 0 and 1, mod of log x becomes minus log x because log x is negative. For this interval, log x is negative. So mod of log x becomes minus log x. Already there is minus. Minus of minus becomes plus. E power log x. E power log x base e. I can simplify this further. Minus means minus 1. Minus 1, take it up. See, minus log x could be written as minus log x base e is equal to log x power minus 1 base e. Correct? Minus means minus goes up to the power minus 1. X power minus 1 is 1 by x. Correct? So this becomes log x power minus 1. So I'll write this as e power. This will be e power minus log x is log x power minus 1. Log x power minus 1 base e. This is if x is greater than or equal to 1. And e power log x will be x. That I'll write in the next step. This will keep as it is. E power log x base e. This is for x between 0 and 1. And we know that e power log of f of x is f of x. So using that condition, I'll write e power log f of x. E power log f of x is f of x. If the base is not given, take the base as e. E power log f of x is f of x if f of x is positive. Correct? F of x should be positive. Log f of x. Log f of x defined only if f of x positive. So e power log f of x, f of x. F of x is positive. So now x is positive only in both the cases, right? 0 to 1 and greater than or equal to 1. So e and log will cancel out. E power log f of x, f of x. E power log x power minus 1 is x power minus 1. So it becomes 1 by x. This is 1 by x. If x is greater than or equal to 1. And e power log x is x if x lies between 0 and 1. This is f of x. And need to find the continuity and differentiability of this. The doubtful point is only x equal to 1. So at x equal to 1, check the continuity of the function. Also check the differentiability of this function, f of x. F of x. Need to check the continuity of this function. At x equal to 1, verify left hand limit and right hand limit. At x equal to 1, find out left hand limit. Only doubtful point is at x equal to 1. Rest everywhere the function is continuous. Limit x tends to 1 minus. Less than 1. X less than 1 this is a function. Correct? X. So limit of 1 is 1. Right hand limit. Limit x tends to 1 plus. Limit x tends to 1 plus. 1 plus means slightly greater than 1. For x greater than 1, the function is 1 by x. So limit of 1 by x, limit x tends to 1 of 1 by x, 1 by 1. 1 by 1 is 1. Even f of 1 you calculate. F of 1. F of 1 is at x equal to 1. 1 by 1 is 1. So all are equal, correct? Left hand limit equal to right hand limit equal to function value. Therefore the function is continuous at x equal to 1. Therefore I can conclude that left hand limit is equal to right hand limit equal to function value. Implies f is continuous at x equal to 1. F is continuous at x equal to 1. Also you can check the differentiability of this function. F dash of x you find out. F dash of x. Derivative of 1 by x is minus 1 by x square. Derivative of x is 1. So this will be minus 1 by x square. This is for x greater than or equal to 1. Derivative of x1. This is for x between 0 and 1. Correct? F dash of 1 minus. 1 minus means x less than 1. X less than 1 derivative is 1. Correct? Left hand limit is for x tends to 1 minus. X less than 1. Correct? X I used. For x greater than 1, use 1 by x. 1 by 1. So f dash of 1 minus sounds. F dash of 1 minus. That is derivative for x less than 1. X less than 1 derivative is 1. And f dash of 1 plus. 1 plus means x is greater than 1. X greater than 1 minus 1 by x square. Put x equal to 1 and write minus 1 by 1 square. Minus 1 by 1 square, which is equal to minus 1. So left hand derivative is not equal to right hand derivative. Function is not differentiable at x equal to 1. Correct? Therefore I can conclude that f dash of 1 minus is not equal to f dash of 1 plus. F dash of 1 minus is not equal to f dash of 1 plus. Therefore f is not differentiable at x equal to 1. F is not differentiable at x equal to 1. You must know about the basic knowledge about the log function. For every question there is some basic thing that you must learn. Then only it's possible. Okay, this is a basic thing about log function, where it is positive and where it is negative, so that you can remove this modulus function. So number of points where the function is not continuous. Function is continuous everywhere. Even at the doubtful point at x equal to 1, the function is continuous. Correct? Function is continuous even at x equal to 1. But the function is not differentiable at x equal to 1. Function is not differentiable at x equal to 1. Function is continuous at x equal to 1. In fact, the function is continuous everywhere. Even at the doubtful point, the function is continuous. So m is 0 and n is 1. 0 plus 1 is equal to 1. Option C. Question asked on 31st of January, second shift, JEE in 2024. Okay. I required a simple question. You must know the nature of the log function, how it behaves, where it is positive, where it is negative, for which values of x log function is positive and which values of x log function is negative, you must know. Then you can answer it very easily. And the very basic knowledge of continuity and differentiability is required. Okay. So, not differentiable at x equal to 1 only. Number of points of non-differentiability is 1. The discontinuity is 0. The number of points of discontinuity is 0. The function is continuous everywhere. Not differentiable at exactly 1 point. That is at x equal to 1. So 0 plus 1 equal to 1. Answer is option C. Move on to the next one. Question number 10. A function f from R to R is defined by this. F of x equal to various cases are given. Want to find alpha square plus beta square. Function is continuous at x equal to 0. Function is continuous means you can use left hand limit equal to right hand limit equal to function value and get the answer. Quite simple question asked on 4th of April 1st 2024. F is continuous at x equal to 0. Find out left hand limit first. Left hand limit. Limit x tends to 0 minus. Limit x tends to 0 minus. 0 minus means x less than 0. I need to use 1 minus cos 2x by x square. 1 minus cos 2x divided by x square. Correct? This is equal to 2 square divided by 2. 4 by 2 is equal to 2. Because the reason is limit x tends to 0. 1 minus cos px by x square is p square by 2. Learn this result if you don't know. 1 minus cos px divided by x square is equal to how much? P square divided by 2. Limit x tends to 0. 1 minus cos px by x square is equal to p square by 2. P is 2. So 2 square by 2. 4 by 2 is equal to 2. Right hand limit you find out. X tends to 0 plus. Limit x tends to 0 plus. 0 pluses, that is for x greater than 0, beta into root of 1 minus cos x by x, beta into root of 1 minus cos x divided by x, which you can write it as limit x tends to 0 plus, I can take this x inside the root. If it goes inside the root, becomes x square, correct? Because x is already positive here. Root of x square is mod x, you must know this. Root of x square is mod x. Root of x square is equal to mod x. And mod x is equal to x if x is greater than or equal to 0. And mod x is minus x if x is less than 0. You must know this. Okay? And x tends to 0 plus means x is positive. So positive means x. X could be written as mod x. Mod x is root of x square. When it goes inside the root, it becomes x square. So this becomes beta into square root of 1 minus cos x divided by x square. And 1 minus cos x by x square is how much? Half. See, 1 minus cos px by x square is p square by 2. Observe that p is 1 here. P is 1. 1 minus cos of 1x, that is cos x. Put p is equal to 1. I get 1 square by 2, 1 by 2. So this will be beta into root of 1 by 2. That is beta into 1 by root 2. So beta by root 2. Beta by root 2, right hand limit. So function is continuous at x equal to 0. Since f is continuous at x equal to 0, since f is continuous at x equal to 0, left hand limit equal to right hand limit equal to function value. Left hand limit is equal to right hand limit is equal to function value. Left hand limit is how much? Left hand limit is 2. Right hand limit is beta by root 2. Beta by root 2. F of 0 at x equal to 0, the function value is alpha. So f of 0 is alpha. So if we equate the first and last, we'll get alpha is equal to 2. Correct? Alpha is equal to 2. If we equate these two, I'll get beta is 2 root 2. Cross multiply. Correct? Beta is equal to, equate these two, the first and second, cross multiply. Beta is 2 root 2. Alpha is 2. Therefore, alpha square plus beta square defined. Therefore, alpha square plus beta square. Alpha is 2 square plus beta is 2 root 2, the whole square. 2 square is 4. 2 root 2 square, 2 square 4, 4 root 2 square 2, 2 into 4 is 8, 8 plus 4, answer is 12, option B. Question asked on 4th of April, first shift, JEE Main 2024. Quite a simple question. Please go through it. Is that clear? Move on to the next one. Question number 11. F from open interval 0, pi map to R be a function given by this. Okay. Want to find a and b are integers. F is continuous at x equal to pi by 2. Find a square plus b square equal to how much? So because the function is continuous at x equal to pi by 2, I can use left hand limit equal to right hand limit equal to function value. First find left hand limit at x equal to pi by 2. Left hand limit is limit x tends to pi by 2 minus. X tends to pi by 2 minus. X tends to pi by 2 minus of the function f of x. X tends to pi by 2 minus. Pi by 2 minus means x is less than pi by 2. Pi by 2 minus means value of x is less than pi by 2. You have to use this. 8 by 7 to the power tan 8x by tan 7x. 8 by 7 to the power of tan 8x by tan 7x. Limit x tends to pi by 2 minus 8 by 7 8 by 7 is a number greater than 1. Observe that. Okay. Tan 8x by tan 7x is what? Tan 8x divided by tan 7x. As x tends to pi by 2 minus, 8 into x will tend to 8 into pi by 2, 4 pi. Tan of n pi is 0. Tan of 2n plus 1 pi by 2 is not defined. You must know that tan of n pi is equal to 0. Tan of n pi is equal to 0. Okay, for all n belongs to Z. And tan of 2n plus 1 pi by 2 is not defined. You must know this. Tan of 2n plus 1 pi by 2 is not defined. For all n belongs to Z. You must know this. Okay. Tan of n pi is 0 for all n belongs to Z, and tan of odd multiple pi by 2 is not defined. That means it may tend to infinity or minus infinity depending upon the value of n. So this power, you see, constant on this power, 8 into pi by 2 is 4 pi. As x tends to pi by 2, 8 into pi by 2 is 4 pi. Tan of 4 pi is 0. Tan of 4 pi is 0. And this is tan of 7 pi by 2, that is tending to infinity, maybe plus infinity or minus infinity. So it's an odd multiple of pi by 2, correct? So in that case, now denominator is becoming quite large and numerator is 0 in the power I'm telling. So 8 by 7 to the power, 0 by some very large quantity, positive or negative. Okay, so 8 by 7 to the power 0 I can tell. This is becoming 8 by 7 to the power 0. 8 by 7 to the power, in the power, the numerator is tending to 0, denominator is a quite large positive number or quite small negative number. So 0 by infinity or 0 by minus infinity, in both the cases it is 0. 8 by 7 power 0, which is 1. So left hand limit is 1. Okay, x tends to pi by 2 minus left hand limit we got. And even the function value is directly I can tell. At x equal to pi by 2, the function value is a minus 8, f of pi by 2. At x equal to pi by 2, the function value is a minus 8. And x tends to pi by 2 plus x greater than pi by 2, use this third line, right hand limit. Right hand limit is limit x tends to pi by 2 plus limit x tends to pi by 2 plus x tends to pi by 2 plus x greater than pi by 2 is 1 plus mod of cot x to the power b by a mod of tan x. 1 plus mod of cot x, this entire thing to the power b by a into mod of tan x, b by a into mod of tan x. Okay, this is equal to x tends to pi by 2 plus means slightly greater than pi by 2. It lies in second quadrant. Second quadrant, cot function and tan function both are negative. So mod of cot x becomes minus cot x and mod of tan x becomes minus tan x. Mod of cot x minus cot x. Mod of tan x minus tan x. Because in the second quadrant both tan and cot are negative. So this becomes limit x tends to pi by 2 plus what we get is 1 minus cot x to the power b by a into mod of tan x is minus tan x. And you know tan and cot are reciprocals. We have the result limit x tends to 0, 1 plus x to the power 1 by x is e. You must know that. I'll write here. The result you should know. I'll write here. Limit x tends to 0. Limit x tends to 0. 1 plus x to the power 1 by x. What is present here? The reciprocal should be present in the power. In that case, it becomes equal to e. So I'll be using that. This is equal to limit x tends to pi by 2 plus limit x tends to pi by 2 plus what we have is 1 minus cot x, 1 minus cot x to the power minus 1 by tan x to the power minus tan x, because tan and cot are reciprocals, no? I can write minus tan x as minus 1 by cot x. This entire thing will be e here, okay, to the power b by e. B by e. 1 minus cot x power minus tan x, that becomes e according to this. Minus cot x reciprocal is minus tan x, correct? 1 minus cot x to the power minus 1 by cot x, correct? What is there inside the bracket? No, that is e. So this becomes e power b by a. b by using this result. Hope it's clear. Limit x tends to 0, 1 plus x to the power 1 by x is e. So limit x tends to pi by 2 plus 1 minus cot x power minus tan x, that becomes e power b by a. Anyway, the powers gets multiplied so that I get the previous step. Now use continuity at x equal to pi by 2. Left hand limit equal to right hand limit equal to function value. Since f is continuous at x equal to pi by 2, f is continuous at x equal to pi by 2, what I can write? Left hand limit equal to right hand limit equal to function value. Left hand limit is equal to right hand limit is equal to function value. Left hand limit is what? Left hand limit is 1. Right hand limit we got e power b by a. E power b by a. And the function value at x equal to pi by 2 we got a minus 8. If we equate the first and last, I'll get a minus 8 equal to 1, implies a equal to 9. A is equal to 9. And if we equate the first and second here, e power b by a equal to 1, so b by a should be 0. E power b by a is equal to 1. 1 is e power 0. That means b by a equal to 0. B by a is equal to 0. So b by a ratio becomes 0 if numerator is 0 and denominator is non-zero. Denominator is already we got, a is equal to 9 we got. So b by 9 is 0, means b is equal to 0. A and b both we got. We want to find a square plus b square. A is 9 and b is 0. 9 square plus 9 square is 81. 81 plus 0. 81 is the answer. Question asked on 9th of April, first shift, JEE in 2024. A is equal to 9, b equal to 0. b by a is 0 means b should be 0. A is equal to 9. 9 square plus 0 square. 81 plus 0, 81. Okay. Move on to the next one. Hope it's clear. Learn all the important things on this. This is a limit theorem we must know, and also a basic knowledge of trigonometry is required. Move on to the next one. Question number 12. Limit function f of x given like this is continuous function at x equal to 0. Want to find b by a. So function is continuous at x equal to 0. Use left hand limit equal to right hand limit equal to function value at x equal to 0. Left hand limit find out at x equal to 0. At x equal to 0, left hand limit. Limit x tends to 0 minus. X tends to 0 minus. X less than 0 is this function. Tan of a plus 1x plus b tan x divided by x. Tan of a plus 1x. Tan of a plus 1x plus b tan x divided by x. Correct? That is left hand limit for x less than 0. I use that. Now I can separate the terms and write this in the form of tan theta by theta. Correct? Limit x tends to 0 minus tan of a plus 1x divided by x plus b into tan x by x. I'll be using this result. Limit x tends to 0. Tan mx by tan mx is a by b or m by n. Limit x tends to 0. I'll use tan ax by tan bx. Tan ax divided by tan bx. Limit x tends to 0. Tan ax by tan bx is a by b. This is the application of limit theta tends to 0. Tan theta by theta 1. From there only we got this. So just see the coefficient of x in the numerator and coefficient of x in the denominator. That's the answer. A by b. X coefficient a. X coefficient b in the denominator. So here the coefficient of x a plus 1. Denominator coefficient of x 1. So a plus 1 by 1. Using this result, okay, limit theorem, you must learn the limits of trigonometric functions. So limit x tends to 0 minus tan of a plus 1x divided by x will be a plus 1 by 1. That is a plus 1. A plus 1 divided by 1. And limit x tends to 0, b into tan x by x. Tan x by x 1 as x tends to 0. So b into 1, that is b. So I am getting a plus b plus 1. Left hand limit is a plus b plus 1. Now go to right hand limit. And the function value at x equal to 0 is 3. Also f of 0 is equal to 3. F of 0. The function value at x equal to 0 is 3. Now find out the right hand limit. Right hand limit is limit x tends to 0 plus. Limit x tends to 0 plus. You can simplify it here. X root x you keep as In the numerator, now I can take root x common there. First I'll simplify this as root of, in this first root, no, I can take x common. If you take x out from that terms inside the root, x common, what remains? A plus b square x. A plus b square x, correct? Minus root of ax, you can write root a into root x divided by, even this type of question commonly asked many times in the PYQs, you can see this type of question. Okay, this part I am telling. We'll be covering all the PYQs before the January shift exams 2025 to 2019. All the shifts, all the chapters will be covered in detail. Along with that, even the synopsis also will be done. B root A into x root x. We can take root x common from the numerator and cancel the denominator, correct? So what I'm going to get is limit x tends to 0 plus, you can take root x common here. So what do you get? Root of a plus b square into x minus root a divided by b root a into x root x. So root x is going to cancel that. Now it takes 0 by 0 form. If you apply limit directly, it becomes 0 by 0 form. Put x equal to 0 here. A plus b square into 0. B square into 0 is 0. 0 plus a. Root a minus root a is 0. Here also. Here b root a into 0. 0. After cancelling root x from numerator to denominator. Correct? So it takes 0 by 0 form. We can apply L'Hopital's rule. Differentiate both numerator and denominator separately. Apply L'Hopital's rule. Apply L'Hopital's rule. Differentiate numerator and denominator separately. What do we get? Limit x tends to 0 plus. After cancelling this root x, denominator will be, if you differentiate, it becomes b root a. Derivative of x is 1. Numerator differentiate 1 by 2 root of a plus b square into x, correct? Into derivative of a plus b square x. Derivative of a is 0. Derivative of b square x is b square. And derivative of constant is 0. Apply limit now, x equal to 0. Then you put x equal to 0, b square by 2 root a, this is 0, correct? What remains is b square divided by 2 root of a plus 0, that is root a, divided by b root a. 1b is going to cancel here, 1b remains, divided by 2 into root a comes down, root a into root a becomes a, correct? 1b has been cancelled here, 2 comes to denominator, root a gets multiplied to denominator, root a into root a becomes a, so b by 2a. Now use the condition, left hand limit equal to right hand limit equal to function value. Since f is continuous at x equal to 0, since f is continuous at x equal to 0, what we have is left hand limit equal to right hand limit equal to function value. Left hand limit is equal to right hand limit is equal to function value. Left hand limit we got a plus b plus 1, correct? A plus b plus 1. Right hand limit we got b by 2a. B by 2a is equal to the function value we got it as 3. We want to find the value of b by a. This is cross multiply, equate these two. This much is enough. So b by 2a equal to 3. B by 2a is equal to 3 implies b by a is equal to 6. 2 you cross multiply, 2 into 3, 6. So b by a equal to 6. This part was not required. B by A equal to 6. Question asked on 8th of April, second shift, JEE Main 2024. Use this theorem, important. And also we are using L'Hopital's rule here. Differentiate numerator and denominator separately and apply the limits. Okay. So root x has been cancelled there from numerator denominator. B root a is constant, derivative of x1. The derivative of root x 1 by 2 root x. Derivative of constant is 0. Derivative of root x 1 by 2 root x. And this is not x. So further differentiate. Derivative of a is 0. Derivative of b square x is b square. So b square by 2 root a after applying limit. B square by 2 root a. That root a comes down. 1b has been cancelled. B by 2a. That's the right hand limit. All equal. Left hand limit equal to right hand limit equal to function. I'll give the value of b by a. Please go through it. Move on to the next one. Question number 13. F of x given like sine 3x plus alpha sin x minus beta cos 3x by x cube for x belongs to R is continuous at x equal to 0. Find f of 0. Function is continuous at x equal to 0 means limiting value equal to function value. Okay. Since f is continuous at x equal to 0, since f is continuous at x equal to 0, f is continuous at x equal to 0. What we have? Limiting value is equal to function value. Limit x tends to 0 f of x is equal to f of 0. Limit x tends to 0 f of x is equal to f of 0. So limit x tends to 0 f of x. For finding limiting value use this function. Okay. And using that I need to find f of 0. Limit x tends to 0. What is my f of x? Sin 3x plus alpha into sin x minus beta into cos 3x divided by x cube. F of 0. Limiting value equal to function value. As x tends to 0, so denominator is becoming 0, correct? 0 cube 0. So f of 0 is a finite number according to the options, right? So limiting value should be finite number. Because f of 0 is finite, limiting value should be a finite number. Otherwise limit does not exist, correct? If denominator is 0, if numerator is non-zero, non-zero by 0 means limit does not exist. But limit is already a finite number because f of 0 is finite, correct? Therefore as x approaches to 0, what we have is denominator is approaching to 0. Implies numerator should tend to 0. Denominator is tend to 0 implies numerator should tend to 0. Apply limit for numerator and you'll get one condition. Put numerator equal to 0. Sine of 3 into 0. Sine 0 0. Sine 0 0. Correct? What we get? Sine 0 0 plus alpha into sine 0 0 minus beta into cos of 3 into 0. Cos 0 is 1. Correct? That should be equal to 0. I'll get minus beta equal to 0 implies beta equal to 0. Beta I got 0. As x is approaching to 0, denominator is 0. So I insist the condition that numerator should approach 0. So that it takes 0 by 0 form, we can apply L'Hopital's rule. If it takes 0 by 0 form, one can apply L'Hopital's rule and get a limiting value as a finite number. Correct? So denominator is 0. So numerator also should tend to 0. Okay? Suppose numerator is non-zero. Non-zero by 0 means it becomes infinite. So limit does not exist in that case. But here f of 0, limiting value equal to function value. Function value is already a finite number according to the options. So limiting value should be a finite number. So it should take 0 by 0 form. So if it takes 0 by 0 form, I can apply L'Hopital's rule. Since it takes 0 by 0 form, as it takes 0 by 0 form, apply L'Hopital's rule. Differentiate numerator, denominator separately. Beta we got 0, okay? Beta we got 0. Limit x tends to 0, f of x becomes, limit x tends to 0, f of x will be equal to what? Limit x tends to 0. What we have? Beta is 0. So beta is 0 is substitute there. This part is not there. Beta is 0. What remains is sine 3x plus alpha sin x. What is left is sine 3x plus alpha sin x divided by x cube. Okay. As x approaches to 0, again numerator is tending to 0. Sine 0 0. Alpha into sine 0. 0 by 0 form. So apply L'Hopital's rule here. Applying L'Hopital's rule. Differentiate numerator and denominator separately. What we get? Limit x tends to 0. Derivative of sine 3x. Derivative of sine 3x is 3 times cos 3x. Derivative of alpha sin x is alpha cos x divided by derivative of x cube is 3x square. Now as x approaches to 0, denominator is becoming 0. Again numerator should tend to 0. As x approaches to 0, denominator is approaching 0. Implies numerator should tend to 0. what we get? Putting x equal to 0, 3 into 0, 0, cos 0 is 1, 1 into 3, 3, plus alpha into cos 0 is 1, so I am getting alpha equal to minus 3. From this, I am getting the value of alpha equal to minus 3 using 0 by 0 form, correct? Because as x tends to 0, denominator is becoming 0, numerator sin 0, 0, alpha into sin 0, 0, correct? 0 plus 0, 0, 0 by 0, applying L'Hopital's rule, L'Hopital's rule, I wrote LH rule in short. So differentiate the numerator and denominator separately. Derivative of sin 3x cos 3x into derivative of 3x 3. Derivative of alpha sin x is alpha cos x. Derivative of x cube is 3x square. Now again, as x is approaching to 0, denominator is becoming 0, 3 into 0, 0. So numerator should tend to 0. 3 into cos of 3 into 0, 3 into 0, 0, cos 0, 1, 1 into 3, 3, I wrote. Alpha into cos 0 is 1, 1 into alpha. So alpha plus 3 is 0, alpha equal to minus 3. So alpha is minus 3 I got. So alpha is minus 3 can substitute. Beta already we got 0. Beta is 0, alpha is minus 3. Therefore this becomes, therefore I'll call this star. Equation star becomes, therefore equation star becomes what? Limit x tends to 0, sin 3x, alpha we got minus 3, substitute there, alpha is minus 3 into sin x, beta is 0, this part is gone, 0, correct, divided by x cube, that should be equal to f of 0. Now we can use the formula, trigonometric formula. Sin 3x is 3 sin x minus 4 sin cube x, using the triple angle formula for trigonometry, correct? Limit x tends to 0, what we have? Sin 3x formula, 3 sin x minus 4 sin cube x, 3 sin x minus 4 sin cube x minus 3 sin x, that you keep as it is, divided by x cube is equal to f of 0. 3 sin x will cancel, correct? Minus 4 into sin cube x by x, we can write minus 4 into sin x by x the whole cube. Limit x tends to 0, sin x by x 1. So 1 cube is 1, 1 into minus 4, f of 0 is minus 4 is the answer, option D. I'll write this step, last step. Limit x tends to 0. All these things we can do within a minute. All these things, so much steps are not required. I'm showing all the steps to make you understand, okay? This can be done within a minute if you are very strong in the concepts of limits and continuity, okay? Limit x tends to 0, minus 4 into, what we have is sin x by x the whole cube, correct? Which is equal to minus 4 into 1, minus 4. That is equal to the value of f of 0. Okay, question asked on 5th of April 1st, JEE Main 2024. Hope it's clear. First find the values of alpha and beta using the concept of limit. Then you can find the limiting value. Limiting value equal to function value. So the function is continuous at x equal to 0. We're getting the value of f of 0 from there. Move on to the next one. Fourteenth one. Given f from the closed interval minus 1, 2 map to r, given by this f of x equal to 2x square plus x plus greatest integer value of x square minus greatest integer value of x. Number of points where f is not continuous is how much? To find the points of discontinuity of this function. We know that greatest integer function is discontinuous for integral points. For every integral point, the greatest integer function is discontinuous. Here what is present is greatest integer value of x square and greatest integer value of x. So as x belongs to the interval minus 1 to 2, the concept is this. We know that greatest integer function is discontinuous at the points where it becomes integer. Correct? Is discontinuous at every integral points. You must know this concept. Greatest integer function is discontinuous at every integral points. At every integral points. Greatest integer function is discontinuous at every integral points. So as x belongs to the interval minus 1 to 2, x belongs to the interval minus 1, 2. X belongs to this interval. X square belongs to which interval if I know? X square will belong to the interval 0 to 4, correct? Minimum value of x square is 0, you must know that. X square belongs to the interval 0 to 4. In this interval 0 to 4, which are the integral values you see? X square equal to 0, 1, 2, 3, 4. because greatest integer function is discontinuous at every integral points. So x square equal to 1, x square equal to 0 you can start. X square equal to 0, 1, 2, 3, 4. If x square is 0 means x is equal to 0, taking the positive values. X square is 1 means x is 1. X square is 2 means x is root 2. X square is 3 means x is root 3. X square is 4 means x is 2. Taking the positive values. Okay. X equal to 0, 1, root 2. X square is 1 means even x can be minus 1. Plus or minus 1 is possible actually. Correct? X equal to minus 1 is also possible there. Because minus 1 is included. Correct? Root 2, root 3, 2. Minus 1 is included there. I could write plus or minus 1 for this. Plus or minus 1 I'll write. X square is 0 means x is 0. Because root 0 is 0. X square is 1 means x is plus or minus 1. Because both the values lies there. Plus or minus 1. X square is 2 means x is plus or minus root 2. Minus root is not there. Only root 2 is there. Root 3 minus root 3 is not there. X square is 4 means x is 2. Correct? These are the values I am getting. Only for 1 I am getting plus or minus. Okay? These are the points, the possibility that the function is discontinuous because the x square is becoming integer at these points. At these points x square is becoming integer. Now go to greatest integer value of x. Greatest integer value of x is discontinuous at integral points, we know. This is integral, this is x is becoming integer at minus 1, 0, 1, 2. Correct? So greatest integer value of x can be discontinuous. So we can list out the greatest integer value of x square, points of discontinuity 0, 1, minus 1, root 2, root 3 and 2. For greatest integer value of x, no? For greatest integer value of x, points of discontinuity can be minus 1, 0, 1, 2. And you must be knowing that if you take a discontinuous function and another discontinuous function, difference of those two can be continuous. Continuous plus discontinuous is discontinuous. If you take two discontinuous functions, if you add them or you subtract them, there is a possibility that the function can become continuous. Continuous minus discontinuous is discontinuous. See, which are the points common to these two? 0 is common, minus 1 is common, 1 is common, 2 is common, correct? Minus 1, 0, 1, 2 are the common points in these two for greatest integer value of x square and greatest integer value of x. But root 2 and root 3 is not common points. Root 2 and root 3 is possibly the function is discontinuous at root 2 and root 3, no? Even though this becomes continuous, discontinuous minus continuous is discontinuous. So root 2 and root 3 are definitely the points of discontinuity for the function f of x. Root 2 and root 3, this function is discontinuous. This function will be continuous because root 2 and root 3 are non-integral values. For every non-integral value, the function becomes continuous. Correct? So this is continuous at root and root 3. But this is discontinuous at root 2 and root 3. So discontinuous minus continuous is discontinuous. And this is a polynomial function, correct, of degree 2. This much is polynomial function. So I need to discuss only about these two. Okay? This is continuous everywhere. 2x square plus x is continuous everywhere. I don't discuss about that. So at root 2 and root 3, definitely the function is discontinuous. Now the common points, no, the function can become continuous. There is a possibility because discontinuous minus discontinuous, the difference of two functions which are discontinuous can be continuous. Can be continuous. So I need to verify at 0, 1, minus 1 and 2. So check at x equal to 0. At x equal to 0. At x equal to 0 means I need to find out left hand limit, right hand limit and function value. Okay. Left hand limit you find out. Left hand limit is limit x tends to 0 minus. Limit x tends to 0 minus. I'll consider only this much. This part I won't consider at all. Okay. That part is already continuous. I'm considering only this much. Only this much because this function is only the possibility that the function can be discontinuous or continuous. So I'm using that. So greatest integer value of x square, correct, minus greatest integer value of x. 0 minus means what? 0 minus means slightly less than 0. Say take minus 0.1. Minus 0.1 square will be 0.01. 0.01 integral value is 0. Correct? Minus. Integral value of minus 0.01 is minus 1. So minus of minus 1 becomes plus 1. Left hand limit is 1. Right hand limit, find out. Right hand limit. Limit x tends to 0 plus. Limit x tends to 0 plus of this function. Greatest integer value of x square minus integral value of x. 0 plus means slightly greater than 0. 0.1 I take. 0.1 square is 0.01. Integral value of 0.01 is 0. And integral value of 0.1 is 0. 0 minus 0 is 0. So left hand limit is not equal to right hand limit. LHL is not equal to RHL. Therefore, I can conclude that the function greatest integer value of x square minus x is discontinuous at x equal to 0. Is discontinuous at x equal to 0. Like that, I can check the discontinuity at x equal to 1. Continuous or discontinuous at x equal to 1, you check. At x equal to 1. At x equal to 1. Find out left hand limit and right hand limit. Left hand limit is limit x tends to 1 minus. Limit x tends to 1 minus of the function integral value of x square minus integral value of x. 1 minus means slightly less than 1. Say 0.9. 0.9 square is 0.81. Integral value of 0.81 is 0. 1 minus means slightly less than 0.9. Integral value of 0.9 is 0. 0 minus 0 is 0. Right hand limit, you find out. Right hand limit. Limit x tends to 1 plus. Limit x tends to 1 plus of integral value of x square minus integral value of x. 1 plus means slightly greater than 1. 1.1. 1.1 square will be 1.21. Integral value of 1.21 is 1. Integral value of 1.1 is 1. 1 minus 1, 0. Even you calculate at x equal to 1 the function value. Call this function as g. G of 1. Okay. G of 1 if you calculate also it is 0 only. We'll call this function as g. G of x. So g of 1 if you calculate. G of 1 is equal to integral value of 1 square, that is 1. 1 minus 1 is equal to 0. The function becomes continuous at x equal to 1, correct? At x equal to 1 it is continuous. Therefore, that is one conclusion. At x equal to 1 it is continuous. Next, I need to check at x equal to 2, correct? At x equal to 2, 2 is a right hand point. At right hand point, we need to find only the function value and the left hand limit. Right hand limit we can't find out. X greater than 2 means it goes outside the interval, correct? So only the left hand limit and the function value I need to find out. At x equal to 2, at x equal to 2, I need to find the function value, okay? Function value is what? G of 2. What is G of 2? At x equal to 2. G of x is this. 2 square 4. Integral value of 4 is 4. Minus integral value of 2 is 2. 4 minus 2 is 2. Limit x tends to 2 plus. Limit x tends to 2 plus of greatest integer value of 2 minus, no, not 2 plus. Sorry, 2 minus I need to discuss. I can't discuss 2 plus. 2 plus will go outside the interval, correct? So we can't discuss 2 minus integral value of x square minus integral value of x. 2 minus means what? Slightly less than 2, say 1.9. 1.9 square will be 3.61. Integral value of 3.61 is 3, correct? 3 it becomes. And integral value of 1.99 becomes 1. 3 minus 1 is 2. Therefore, it is equal, correct? G of 2, function value is same as the left hand limit. Therefore, G is continuous. Therefore, what I can conclude is greatest integer value of x square minus greatest integer value of x is continuous at x equal to 2. Is continuous at x equal to 2. Next, we need to check the continuity at x equal to minus 1. At x equal to minus 1 is the left hand point, correct, of the interval. So there we can't find the left hand limit. I can use the function value and the right hand limit. Only two things, function value and the right hand limit at x equal to minus 1. So g of minus 1 you calculate. G of minus 1. So minus 1, g of minus 1 is put x equal to minus 1 directly. Minus 1 square is 1. Integral value of 1 is 1. Minus. Integral value of minus 1 is minus 1. Minus of minus 1 becomes plus 1. Correct? putting x equal to minus 1 directly in the function. Now find out the left hand limit. Sorry, now you have to find right hand limit at x equal to minus 1. Limit x tends to 2 minus 1 plus I have to find out of greatest integer value of x square minus greatest integer value of x. Minus 1 plus means slightly greater than minus 1. Say minus 0.9 I should take. Minus 0.9 if it's square it becomes 0.81. Integral value of 0.81 will be 0. Minus. If you take minus 1 plus means slightly greater than minus 1. Say minus 0.9. Integral value of minus 0.9 is minus 1. So it becomes plus 1. They are not equal. See, they are not equal. Therefore, the function is discontinuous at x equal to minus 1. The function is going to be discontinuous at x equal to minus 1. Integral value of x square minus integral value of x is discontinuous at x equal to minus 1. So points of discontinuity is root 2, root 3. Okay. At 0 it was discontinuous. At 1 it was continuous. Correct. At 1 it was continuous. At 2 also it was continuous. So points of discontinuity is 4. Root 2, root 3, 0 and minus 1. Therefore, the given function f is going to be discontinuous. F is discontinuous at x equal to root 2, root 3, correct, and at 0 and also at minus 1. These are the 4 points of discontinuity. Totally 4 points. 4 points of discontinuity. Answer is option D. Question answered on 5th of April, second shift, 2024. Okay. Using the continuity of the greatest integer function. Look at the common points. At the common points, we need to check. Directly we can't conclude because discontinuous function minus discontinuous function can be continuous. So wherever you get common points, at the common points, you find out the left hand limit, right hand limit, and function value. And at the end points, no need to find everything. So if it is left hand point of the interval, I need to find the function value and the right hand limit. And at the right hand point of the interval, I need to find the function value and the left hand limit. I can't find right hand limit there. Okay. So 4 points of discontinuity, which is mentioned here: root 2, root 3, minus 1 and 0. Correct? At minus 1 it is discontinuous because the function value is not equal to the right hand limit at that point, x equal to minus 1. Minus 1 plus minus 0.9 you take. Minus 0.9 square is 0.81. Integral value of 0.81 is 0. Integral value of minus 0.9 is minus 1. Minus of minus 1 plus 1. Hope it's clear. Move on to the next one. Here also they given the points where the function is not continuous for the greatest integer function. Of course, here the interval is 0 to infinity, including 0, excluding infinity. And we want to find the points of discontinuity in the interval 0 to 8 only. In the interval 0 to 8. That is the set S. Okay, that is set S is the points of discontinuity in the interval 0 to 8. And summation of A belongs to S, A to find out. Sum of the values of A to find out. Sum of the values of A, where A lies in the set S. Set S is points of discontinuity in the interval 0 to 8. So given function f of x could be written as f of x, you can write it as, we can split this. 3 is an integer, no? There is a property of greatest integer function. This is an important property. Greatest integer value of x plus n is equal to greatest integer value of x plus n for all n belongs to z. You must know this. Okay? For every integer you can write this. Greatest integer value of x by 2 plus 3. Because 3 is an integer, I can write this as integral value of x by 2 plus 3. F of x could be written as integral value of x by 2 plus 3 minus integral value of root x. Like this, right? Greatest integer value of x by 2 plus 3 minus integral value of root x. We need to discuss the discontinuity of these two. 3 is anyway constant function, it is continuous. So need to discuss the greatest integer value of x by 2 when it lies. Given interval is 0 to 8. Given x belongs to 0 to 8. You want to find the points of discontinuity in this interval. X belonging to the interval 0 to 8. So x by 2 belongs to which interval? X by 2 will belong to the interval 0 to 4. In the interval 0 to 4, which are the integers? 0, 1, 2, 3, 4. Correct? I need to find where x by 2 is integer. X by 2 is integer. X by 2 is integer implies x by 2 is equal to 0. X by 2 equal to 1, 2, 3, 4. If x by 2 is 0, x is equal to 0. X by 2 is 1 means x is 2. X by 2 is 2 means x is 4. X by 2, 3 means x is 6. X by 2 is 4 means x is 8. These are the points of discontinuity for the function greatest is the value of x by 2. Possible integral values. I mean, what are the integral values are there in that interval I wrote. Where x by 2 becomes integer in that interval I wrote. Now come to this. X belongs to 0 to 8 as x belongs to the interval 0 to 8. Root x belongs to which interval? Root x will belong to the interval 0 to root 8. Root 8 is 2 root 2, correct? 0 to 2 root 2. Here, root x integer for which values? Root x is integer implies root x is equal to 0, 1, 2, correct? Root x equal to 3 is not possible, correct? Only 0, 1, 2. 3 will go beyond that, correct? 2 root 2 is 2.8 nearly. So that's 3 is not possible. So root x is 0 means x is 0. Root x is 1 means x is 1. Root x is 2 means x is 4, correct? 3 points I am getting here. So which are the common points here? 0 is a common point. 1 is not a common point. 4 is a common point, correct? 0 and 4 are the two common points. I need to check the continuity at 0 and 4. At 2 it is discontinuous. At 2 it is discontinuous. At 6 it is discontinuous. At 8 it is discontinuous. I need to check at 0. 1 also is not a point of discontinuity, correct? 1 is not common here. 1 is discontinuous. Only at 0 and 4 are the common points, correct? 0 is present here, 0 is also present here. 4 is present here, 4 is also present here. So at 0 and 4, I need to check whether the function is continuous or not. At x equal to 0, check. At x equal to 0. At x equal to 0. Oh, I need to check at x equal to 0 whether the function is continuous or not. So I need to find f of 0 and right hand limit. Left hand limit I can't find out that, correct? So f of 0 is how much? F of 0. F of 0. 0 by 2, 0, correct? 0 plus 3 minus root 0 is 0. Integral value of 0 is 0. So f of 0 is equal to 3. Now find out the right hand limit at x equal to 0. Limit x tends to 0 plus of f of x. That is limit x tends to 0 plus. Limit x tends to 0 plus. 0 plus means right side of 0, correct? What is my function? Integral value of x by 2 plus 3. Integral value of x by 2 plus 3 minus integral value of root x. How much is this? X tends to 0 plus means slightly greater than 0, 0.1. 0.1 by 2, 0.05. Integral value of 0.05 is 0, correct? This will be 0 plus 3 minus 0 plus means slightly greater than 0. Root of that is also 0 point something. Root of 0.1 is 0 point something. Integral value of 0 point something is 0. So it becomes equal to 0. So it's 3 itself. So it is continuous. Given function f is continuous at x equal to 0. F is continuous at x equal to 0. Function is continuous at x equal to 0. Now check at x equal to, another doubtful point is at 4, correct? 0 and 4 are the common points. Now at x equal to 4 you check. At x equal to 4. What is f of 4 you find out? F of 4 is, substitute here, integral value of 4 by 2 plus 3 minus integral value of root 4. 4 by 2 is 2. Integral value of 2 is 2. Root 4 is 2. Integral value of 2 is 2. Plus 2 minus 2 will cancel. 3 I am getting. Find out. I can't find out. Yeah, I can find out both the left hand limit and right hand limit. It's 4 is not an endpoint, right? 8 is an endpoint. At 8 it is, anyway, it is discontinuous. If you want, you can check. Okay. At x equal to 4, I need to find out the left hand limit and right hand limit. Left hand limit. Limit x tends to 4 minus. Because 4 is not an endpoint, correct? So 4 minus. 4 minus means slightly less than 4 of this function. Integral value of x by 2. Integral value of x by 2 plus 3 minus integral value of root x. 4 minus means slightly less than 4. 3.99. 3.99 by 2 is 1 point something, correct? It will be 4 by 2 is 2. 3.99 by 2 will be 1 point something. Integral value of 1 point something is 1. 4 minus means slightly less than 4. Root of 3.99, that will be 1 point something. Root 4 is 2. Root of 3.99 is 1 point something. Integral value of 1 point something is 1. So this will become 3. Find out right hand limit. Right hand limit is limit x tends to 4 plus. Limit x tends to 4 plus of greatest integer value of x by 2 plus 3 minus integral value of root x. 4 plus means slightly greater than 4. 4.1. 4.1 by 2 is 2 point something. Integral value of 2 point something is 2. Plus 3 minus 4 plus is 4 point something. Integral root of 4 point something is 2 point something. Integral value of 2 point some 4 plus means slightly greater than 4. So root of 4 point something. Root of 4 point something is 2 point something. Integral value of 2 point something is 2. So this becomes equal to 3. Correct? Therefore the function is continuous at x equal to 3. At x equal to 3, the function at x equal to 4, the function is continuous. F is continuous at x equal to 4. F is continuous at x equal to 4. It's not a point of discontinuity. 4 was a common point. See, at the common point 4, the function is becoming continuous. At the common point x equal to 0, it is becoming continuous. Continuous at x equal to 0 and x equal to 4. Correct? So points of discontinuity are 1, 2, 6 and 8. If you want, you can check at x equal to 8 if you have a doubt. If you want, because 8 is the right end point of the interval, correct? So f of 8 you calculate. F of 8 will be, if you want to calculate here, f of 8 is equal to how much? 8 by 2 is 4. Integral value of 4 is 4 plus 3 minus root of 8 is 2 point something. Integral value of 2 point something is 2. So how much you get? 4 plus 3, 7 minus 2, 5. Correct? If you find out the left hand limit at x equal to 8, 8 minus means slightly less than 8. 8 by 2 will less than 8. 7 point something by 2. 8 by 2 is 4. 7 point something by 2 is 3 point something. Integral value of 3 point something is 3. 3 plus 3 becomes 6. Correct? So if you find out the right hand limit at x equal to 8, we are finding left hand limit at x equal to 8. 8 minus of f of x will be equal to how much? 8 minus means 7 point something. 7 point something by 2 is 3 point something. Integral value of 3 point something is 3 plus 3 minus root of 7 point something is 2 point something. 2 point something integral value is 2. Correct? 3 plus 3, 6. 6 minus 2 becomes 4. See, function is discontinuous at x equal to 8. So points of discontinuity are 2, 6, 8 and 1. Okay? That is sum of the values of a you want to find out. So points of discontinuity are 1, 2, 6 and 8. So sum of the values of a to find out. That means 1 plus, at 1 it is discontinuous, at 2 it is discontinuous, at 6 it is discontinuous and 8 also it is discontinuous. 1, 2, 6 and 8. Add this. 1 plus 2, 3. 3 plus 6, 9. 9 plus 8 is 17. So 17 is the answer. Question answer on 6th of April, second shift, JEE Main 2024. Move on to the next one. The function f of x given like this is continuous at x equal to 0. Find the value of a square. A square is asked. So we can simplify this first by using 72 is 9 into 8. 72 power x you can write 9 power x into 8 power x. Correct? 72 power x is 72 is 9 into 8. 9 into 8 whole to the power x, which is equal to 9 power x into 8 power x. Correct? 9 power x into 8 power x. So 72 power x minus 9 power x minus 8 power x plus 1. We can simplify this as 9 power x into 8 power x minus 9 power x minus 8 power x plus 1. Correct? From the first two terms, we can take 9 power x common. What remains is 8 power x minus 1. Here minus 1 common. 8 power x minus 1. 8 power x minus 1 is common. 8 power x minus 1 into 9 power x minus 1. So simplifying the numerator of that like this. 8 power x minus 1 into 9 power x minus 1. Simplification is shown. This is a very familiar question. In many of the books, you can find this type of question. It's a commonly asked question. In many of the books, in the exercise problem like Singh, John, Aryan, this type of question is commonly found. Okay. And also, I'll be using the theorems here. Limit x tends to 0, 1 minus cos x by x square is half. I'll be using this. Limit x tends to 0, 1 minus cos x divided by x square is equal to half. I'm using this. And also, I'll be using this. Limit x tends to 0. A power x minus 1 by x is log a. A power x minus 1 by x is log a base e. I'm using this. So what I'll do is write the numerator in this form. 8 power x minus 1 into 9 power x minus 1. Simultaneously I'll rationalize. Denominator is root 2 minus root of 1 plus cos x. There I multiply and divide by root 2 plus root of 1 plus cos x. For x not equal to 0 means limiting value. Okay. Function is continuous means limiting value should be equal to function value. So limiting value will find out. Limit x tends to 0 f of x. Limit x tends to 0 f of x, which is equal to limit x tends to 0. Limit x tends to 0. Numerator is, I'll write in the form of 9 power x minus 1 into 8 power x minus 1. Writing this numerator in this form. The simplification is shown here. Correct? 8 power x minus 1 into 9 power x minus 1. 8 power x minus 1 into 9 power x minus 1. Denominator is root 2 minus root of 1 plus cos x. There you multiply and divide by the conjugate. Multiply and divide by root 2 plus root of 1 plus cos x. Root of 1 plus cos x. Denominator becomes a plus b into a minus b, which is a square minus b square. This is a minus b into a plus b, which is a square minus b square. What we get? Limit x tends to 0, 8 power x minus 1 into 9 power x minus 1 divided by, here I am using a minus b into a plus b, which is a square minus b square, root 2 square minus of root of 1 plus cos x the whole square. And for this you can apply limit. There is no harm, no? Apply limit for this directly. So what you get if you apply limit for this, limit x tends to 0. Limit x tends to 0 because limit of the product is product of the limits. Limit of f into g is limit of f into limit of g. So limit x tends to 0, what you get is root 2 plus root of 1 plus cos x. So this is what you get from this. Limit x tends to 0. This part will be, apply limit here, cos 0 is 1, 1 plus 1 to root 2, root 2 plus root 2, 2 root 2. That we can keep outside. This part is kept outside, we can keep outside directly. Correct? I can write this term first. This is 2 root 2. Applying limit becomes 2 root 2 because cos 0 is 1. Applying limit x equal to 0, cos 0 is 1, 1 plus 1 2, root 2 plus root 2, 2 root 2. 2 root 2 is kept outside. Limit x tends to 0. For numerator and denominator, what I'll do is I'll divide by x square. 8 power x minus 1 into 9 power x minus 1 is there, no? You divide by x for this. Divide by x for this. That means you divide it by x square. Denominator is root 2 square is 2. minus of root of 1 plus cos x square is 1 plus cos x. I'm dividing by x square for denominator also. This is 2 minus 1, 1. 1 minus cos x by x square, which is half, as I told you. Using this. Limit x tends to 0. 1 minus cos x by x square is half. Correct? This becomes 1 minus cos x by x square, which is half. And using this, limit x tends to 0. 8 power x minus 1 by x is log a. Instead of a, we have 8 here. 8 power x minus 1 by x is log 8. This becomes log 8. This becomes log 9. This becomes half. So what I'm getting is the limiting value is going to be equal to 2 root 2 into log 8 into log 9 log 8 into log 9 divided by, this is half. 1 minus cos x by x square is half. This 2 goes up, correct? Becomes 4 root 2 and log 8 is 2 cube, correct? This becomes log 2 cube. Log of 2 cube. And this is log 9. 9 is 3 square. Correct? This power comes down. So what I get is 4 root 2. Using the property log a power b is b log a. This becomes 3 log 2. Log 3 square becomes 2 log 3. 3 into 2 becomes 6. 3 into 2 is 6. 6 into 4 is 24. 24 root 2 into log 2 into log 3. This is the limiting value. Correct? Limiting value. The given that function is continuous at x equal to 0. So use limiting value equal to function value. Function value is at x equal to 0 given as a log 2 into log 3. Since f is continuous at x equal to 0, since f is continuous at x equal to 0, I can write that limiting value equal to function value. F of 0 function value is equal to limiting value. Limit x tends to 0 f of x. F of 0 is given as at x equal to 0, function value is given as a log 2 log 3. So a log 2 log 3, a log 2 into log 3 is equal to limiting value. Just now we calculated here, so much of work we did and got the answer as 24 root 2 log 2 log 3. 24 root 2 into log 2 into log 3. Cancelling the identical terms on both sides, log 2 into log 3 cancels. Correct? So I'm getting a is equal to 24 root 2. Squaring on both sides, a square becomes 24 square is 576. Root 2 square is 2. 576 into 2. 6 2s are 12, 1 carry. 7 2s are 14 plus 1, 15, 1 carry. 5 2s are 10 plus 1, 1152. Answer is 1152. Option B. Question asked on 4th of April, second shift, JEE in 2024. With this, all the questions of 2024, both January shift and April shift of this continuity and differentiability chapter is completed. Hope you understood this simplification. This question was found in many of the books like Ariant and Singhage. Please work out all the problems of the PYQs. PYQs are the most important thing if you are attending a JEE Mains exam, because many times questions do repeat of the same category. So please practice, first learn all the formulas of the chapter, entire chapter, work out the, learn the formulas and try to write without seeing. The synopsis part should be very strong, then only it's possible to answer the question in the stipulated time. Otherwise it's not possible to complete the paper. And for maths you need to keep 1 hour 20 minutes. Out of 3 hours exam, chemistry you can finish off within half an hour. That's the most important thing. Chemistry you have to finish in half an hour. And physics you can keep 1 hour. Or 1 hour 10 minutes at the most, and remaining 1 hour 20 minutes should be kept for mathematics. Then only you can answer 19 or 20 questions out of 25. Otherwise you'll run out of time. So synopsis has to be very strong. Of course we don't have any shortcut methods for answering JEE level questions. Always it takes more time, but this much of steps is not required actually, but we can solve within 1 minute, or it might take 2 minutes maximum. But I am writing all the steps in detail so that to make you understand. Okay, many more videos will be uploaded in the coming days focusing on synopsis of KCET and JEE. Exclusively for JEE separately I am doing synopsis part for KCET exams and JEE exams. Chapter wise will be done along with examples, and also KCT PYQs from 1984 till 2025 will be done. Chapter wise, all the chapters will be covered, and whichever chapters were not there before, or those topics will be done from 2014 to 25. Hope it's understandable. Probability, 3D geometry, such kind of topics were not there earlier, I think. So will be done only from 2014 to 2025. Even PYQs of JEE exams, JEE mains will be covered from 2025 going back to 2019, conducted by NTA exams, NTA. Okay, and even NCERT syllabus will be covered exercise wise. Videos will be uploaded, and also one shot will be done, chapter wise one shot, important questions will be covered, okay, along with the concepts. Even MCQs for board exams will be done, and many more videos will be uploaded. Please subscribe to my channel, forward to your friends. With this I conclude. Thank you.